So there is a resolution to generate.
Dr. Sagar Karthikeyan, welcome, welcome.
Hi Ravi.
Just a few minutes. We will start our session.
Yes, yes, yes. Tell me, and I forget. Teach me, I may remember. Involve me, I learn. A blessed morning to one and all present here. I am Anuj Kumar on the behalf of PG and Research Department of Physics. It is extend to warm welcome one and all for the second day international conference on advanced materials science, ICAMS 2021. We have successfully completed the first day of the conference yesterday with the help of the participants. I thank for you because your cooperation only we have completed successfully. Yesterday, we have come across two sessions. In the morning session, we have a chief guest from Cambridge University. In the afternoon session, we have a session from University of Delhi. And we have completed the oral presentation yesterday. Remaining 6 more participants are there. Because of due to the time consumption, we will give the time for them. Okay, today for the second day conference, morning session, we have a chief guest from University of Tokyo, Japan, and in the afternoon session, one more chief guest from National Institute of Technology, Tiruchirappalli. And amid that, we have a poster presentation, and also the remaining participants, those who are not presented yesterday, the oral presentation, they are also going to present today. So all these from oral presentation, poster presentation, and the chief guest lectures, you are going to learn a lot of information, and you are going to gain much knowledge. All the things, we hope that all the things enlighten you. Now, science is the greatest creative impulse of our time. It dominates the intellectual scene and forms our life, not only in the material things which it has given us, but also it guides our spirit. Now, I would like to call upon Dr. M. Raja, Assistant Professor, Department of Physics, to introduce our distinguished chief guest.
Good morning, everyone, and warm welcome you all at the session 4 for ICAMS 2021. It's my honor to introduce our chief guest, Dr. Segar Karthikeyan, for this session. Dr. Segar Karthikeyan currently working as a specially appointed researcher in Department of Chemistry and Biotechnology at the University of Tokyo, Japan. He recently got a JSPS fellowship from Japan, PDRA fellowship, and Newton International Fellowship from Aston University, UK. Previously, he was postdoctoral fellow in Yunpok National University at South Korea. Also, he completed his PhD with CSIR SRF in Environmental Technology Division at CLRI, Chennai. He has over than 12 years of research experience in the fields of nanomaterial synthesis, metal oxide catalysts, graphene, solar energy conversion, environmental remediation, fundamental chemistry, and catalysis for energy and environment. In particular, he extensively worked on 4 patents and 1 PCT patent. Dr. Karthikeyan has published 24 first author research articles, 25 co-author research articles in high-impact SCI journals, including Applied Catalysis B Environmental, Applied Materials Today, Chemical Engineering Journal, ACS Applied Materials Interfaces, Journal of Material Chemistry and Desalination, etc. Also, he got more than 10 awards from India and overseas countries. He is a member in Royal Society of Chemistry in UK, American Chemical Society in USA, and International Academic Partner in Africa, Center of Excellence for Development Impact. He also delivered more than 15 invited talks in the international conference. Once again, I welcome you all for ICAMS 2021. Thank you.
Thank you, Raja. Thank you for your nice introduction. Can you hear me? Can you hear my voice, everyone?
Yeah, sir, it's audible.
Okay, so can I start my presentation?
Sir, just a minute, sir, just a minute.
Okay.
Thank you so much, sir, for giving the chief guest introduction. Knowledge is the power in the world which enlightening us. Now, I would like to invite our distinguished chief guest, Dr. Sekhar Karthikeyan, Department of Earth Resource Engineering, University of Tokyo in Japan, to give his lecture. Sir, this is the time to over to you, sir.
Thank you. Thank you very much for the nice introduction, Raja. And thank you very much, Dr. Ravi Kumar, for the invitation to present my work in the International Conference on Advanced Material Science. Yesterday, I listened the conference. It was very nice. And then the organizing committee, also the management is giving excellent support, I guess. The young generation is doing really great. The conference is, I hope these few minutes, the journey is very good for the young generation, especially for motivation. And I would like to share my some research experience during these occasions. Okay, let's start the thing. The conference theme, actually today's theme is the utilization of solar energy for the energy and environmental application mainly. So this is just, I would like to share my experience, like my journey, how I went for this research field, also where I moved this, for example, research, after that moving another places like, okay, and then I initially started wastewater and treatment methods, and whatever the challenges I faced during the research periods, I can share the experience, which will be motivated to the young generation as well as the researchers. Also, the overview of the solar energy recently, everyone focusing the solar energy, sunlight from the sunlight, and some few case studies during my research, also some message for the students. Okay, so actually my journey is started from, it's like a very small village. Actually, I went for the school, especially school, for the food. So that means I cannot afford for even 10 rupees per day that time. So that was the situation I faced. Because why I'm telling these stories is very important for the generations, young generations, which has facilities now. Everyone has the facilities. At the time, when I started the journey, is a very lower journey. So even I went for the Tamil medium school. So it's a very challenging period. So I came across the things like just manage whatever the available source, and then getting experience from the seniors. So just motivated myself, and then I started my journey from small village to schools, and then followed by colleges. Even college, I started my journey is like a Tamil medium school. Okay, and then Tamil medium college, and then my PG is like an English medium. So that was the biggest barriers, because when you move to medium, like the medium is very important. Move to your own language to foreign language, it's a challenging period. So how I face the things, it's very important for the young generations. So you can get motivated. You have the sources already. You have the better knowledge. than I faced this experience. So you can be able to come across this any other field which you like to do. Just motivation is important factor. I want to say the message from this slides. Okay. Okay. So my journey, we started actually after my PG. Dr. Ravi Kumar, I met in Ravi Kumar in the Institute of Advanced Study in Education. Now I call the Tamil Nadu Teachers Education University. Okay, so when we started that time, we used to go for school, and then after that we get the papers for the evaluation. That one paper evaluation for like a 5 rupees, 3 rupees based on the content. So we used to correct the papers, and we will get the money, and then we will survive. Just surviving in Chennai is very challenging in 2009, especially for me. And then after doing these things, I met Dr. Ravi Kumar in your institute. Vivekananda College is working in this department. So his friend came from Central Leather Research Institute, CSIR, Council of Scientific Industrial Research. And then he, okay, so this story why I'm telling, everyone has some the limitations. The means I mean, you have the how can I say? You have the barrier. Like if you once you finish the master, you have to go, for example, teachers. I want to go for education, other IAS coaching or something. You have some mindset, and then you have the limitations. So I would suggest there is no limitation in your knowledge. So you can explore your knowledge and then adopt the social things. Okay. So after the 2009, I got the opportunity to enter the CLRI. So that was very good in atmosphere, as well as the good opportunity. Of course, there is no knowledge on the research. So started journey without salary. For 6 months, I worked in Central Leather Research Institute, especially for the treatment of wastewater, industrial wastewater. Because India, especially Tamil Nadu, Tirupur, and then Erode, as well as Karur, there were big textile industries. Also Karur in Tamil Nadu Newsprint Paper Limited. Also in Ronipet, there are big challenging. They faced a lot of problem for the wastewater treatment process. So usually I get the wastewater and then just do the treatment process and then sequential process. So that time I just learn things, how to do the research. Also, it takes 3 years. Okay, so the journey is started 2010 I registered my PhD in the University of Madras. So I completed 2015. So once I finished my PhD, I applied the Royal Society Newton Fellowship in UK. So it's fortunate to got the fellowship. During the time, I got opportunity to do the teaching and learning. So that time I got a fellow of Higher Education Academy in UK. So after finishing UK, so there was the cultural difference. So you can understand the culturals, and then you can learn from the management skills. So these are all very important factor when you move one country to another country. You will get more knowledge, and then you can explore our own country. So that is very important when you learn from the different multicultures things. So after gaining the cultures, so there is little bit barrier because you cannot access some of the facilities in UK. So in that case, I understood Japan is the best country to access all the facilities, especially high-tech instrument, high-tech technologies. You can access your own. So I understood. Then I applied Japan Society for the promotion of science fellowship. So fortunate to got the fellowships in Kyushu University, and then followed by after finishing this Japan Society space fellowship, then I got an opportunity for specially applied research in University of Tokyo. Now, currently, I'm working in this. So why I'm telling this, you will gain the different cultures and then knowledge and then management skills. These all factors to influence your way of thinking. So that is very important to the multi-dimensional skills. Okay, so these are the wastewater which I faced during my PhD studies and then project assistant during Council of Scientific and Industrial Research. So actually, initially we started a municipal wastewater from different municipalities, also some schools, some of the municipal sector from the Chennai areas. Also industrial wastewater which we received, especially from Tirupur area and then Karur area, also Erode district. So also we received the wastewater from Gujarat Vapi area and then Ankleshwar area. This is very important industrial clusters, Gujarat, Ankleshwar and Vapi. Also we received the water from Kanpur. Kanpur is one of the big tannery clusters. So they used a tanning process and then they discharge the water. So there is biggest problem in the TDS. TDS is one of the biggest challenge for the treatment process. We understood the treatment process and then we have the systematic treatment methods. For example, the nuclear is a little bit challenging. So this one I never tried because this is very complicated process. So municipal wastewater we can try, for example, bacterial process, for example, anaerobic, aerobic treatment process. We just do simple methods and then clean the water. So industrial, it's a little bit complex water. So we need advanced treatment process, also sequential process to eliminate refractory organics present in the water. So we need some advanced techniques to break the organic molecules, and then we discharge the pollution control board standards. So pharmaceutical is one of the biggest complex organics because it's mixed of the solvents. So it's very challenging to eliminate first solvent and then to eliminate the refractory organics in the pharmaceutical sector, which we received from Dr. Reddy's laboratory. Also, we received the water from the Orchid Pharmaceuticals. So this we gave the technological advice to the Orchid and then Reddy's laboratory. Also, we got the wastewater from AstraZeneca, also Reliance Industries in also Dubai. So this wastewater we faced, what are the challenges we faced and what are the methods we given. So I will discuss in the further. So this one, nuclear is very dangerous. We need special care to preserve the radioactive elements, which is a very complicated thing. So we need a cooling system to control the nuclear waste. It is very highly toxic and then radioactive elements. So this one I never tried in during my. Okay, so the simple methods which we taken the picture from the Ankleshwar, Gujarat area, Gujarat industry area. So what they do for the mixture of cluster wastewater, so they receive the water from different industrial clusters. For example, more than 18 or more than 20 industrial clusters, they receive the water, and then they mix with the sewage water. Then it have the bacteria and then things, so it can eat the organics, and then they do equalization, first equalization, and then they do then they will transfer to aerobic biological system, and then followed by aerobic biological system, followed by they do anaerobic system. Anaerobic system, they remove most of the organics, and then they produce gas as well. So we need to care about the loading, the reactor loading, everything we need to care about the anaerobic system. And then anaerobic system, because of the anorexity, so we need activated sludge process. So we need to give oxidation conditions, for example, neutral condition. We need to bring the neutral conditions, and then we need to do secondary clarification to remove the sludges, followed by discharge standards. So this one actually little complicated. They have the bacteria and then some refractory organics in this one. So we cannot reuse the water. So actually, wastewater is not waste anywhere in the globe. So everyone facing the challenges, and then they started recovering, and then they started reusing. So we need different sequence system, and then we need to understand the kinetics mechanism, and then we can eliminate all the organics, and then we can reuse the water. So actually, these are the process which can eliminate the complex organic molecule present in the wastewater. So the first method I can discuss about simple pentan process, which is very simple. Just use iron catalyst and then hydrogen peroxide as a chemical. So it will form the hydroxy radical. So this hydroxy radical is the responsible for elimination of refractory organic compounds or any organic compounds. So it will eliminate it will break the compound. And the thing is, the complex industry wastewater, it cannot eliminate all the complex organic molecules. Okay. So there are a lot of methods, for example, thermal evaporation, thermal treatment, just give the energy to break the organic molecule. Also, they do electrocatalytic system to give the energy, and then they connect with the electrode to the wastewater. So it will form the electric energy. So it will form the electrons, and then it will electron, and then producing OH radical, and then superoxide radical is the responsible factor during this process, and then it will eliminate the organic. So the thing is, we need to give more energy, and then the electrode lifetime is also important. We need to understand the system. So another things, just sonolysis, it's an easy method. We can eliminate some of the organics, which is very few organics from lower concentrations. We can eliminate it using the sonic chemical methods. Also, the microwave methods is also very small refractory organic compounds. We cannot eliminate the complex organics. The ozone is like it's kind of tertiary treatment. So when you do aerobic process, anaerobic process, and then followed by you can do for the ozone system, so to eliminate the bacteria and then the viruses in the treated water. So this means after membrane filtration, so you can use the ozone exchange system to disinfect the water. So we can use the water. So this one cannot use for like the complex treatment process. So actually another one thing, the recently developing thing, sulfate radical based reactions. So we need to design the material, right material to activate the sulfate radical, and then sulfate radical is one of the best radical compared with the hydroxy radical, so which can eliminate any complex organic molecule. So this also people are trying to do recently for sulfate activation. Another one is the light energy is the excellent energy source. Just we need to find the right material to harvest the solar energy, to utilize the energy to eliminate the organics present in the wastewater. But the thing is, we tried light reactions. We cannot utilize for the complex organic molecules. We need to find the proper material to break through this technology. So it will take time to get the breakthrough in future. So, okay, first I will talk to this Penton process initially. So I will focus initially environmental basis first, and then followed by energy sector. Okay, so we started a simple Penton process, and the simple Penton process, which is responsible for any iron-based material. So we can introduce the hydrogen peroxide, it will produce the hydroxy radical and then superoxide radical. So this both are the responsible factor to eliminate the refractory organics in the wastewater. The thing is, we need to work, the pH is 2 to 4. So if you go for 5 to 6, 5 to 7, it will form the sludge, hydroxide sludge or metal hydroxide sludge. This is very biggest problem when you do the Penton process. Okay. So another thing is the catalyst locks. So when you do the Penton process, so it will consume iron and chemicals. So it consumes the chemicals, and then another thing is hydrogen peroxide is the toxic in nature. So we cannot utilize for huge amount of hydrogen peroxide. So what we tried to do, so we integrated with this material, any kind of transition metal like iron-based, copper-based material. We incorporate with this carbonaceous support, and then we introduce the hydrogen peroxide. It consumes very few micromoles, which I'm going to discuss with this one. Okay, so here what we did. So we introduced this iron-based material, metal oxide material. We incorporate with the carbon bed support. This also support as well as acting as a membrane. So it will act as a heterogeneous catalyst when we go for the high concentration wastewater. Our concept is initially zero emission research initiative in leather sectors. So mainly focused on wastewater treatment, zero emissions wastewater. So this one we utilized for advanced technique as well as biological technique. The first principle we introduced, it takes almost 5 years to find the material is having excellent property to produce hydroxy radical. So we first reported and then we patented for the world patent. Okay. So this is the first principle we introduced for the carbon is producing superoxide radical in the presence of oxygen without using any chemicals. So in this material, we utilized in cooperation with the biological molecules, also introduced with some transition metal oxides. So this one, we found fluidized bed reactor initially. The fluidized bed reactor, the thing is that also produced some amount of sludge. We cannot avoid that sludge. So we're trying to eliminate that sludge. We are thinking, and then we try to adopt fixed bed reactor. I'm going to discuss the next thing. So here the thing is the reactor, which we developed the reactors, it requires only 0.3 meter square per meter cube of wastewater. So this one, it's comparatively relatively high, very lower when we conventional technologies. It requires 1 meter square per meter cube of wastewater. So also the retention time we optimized just 1 to 4 hours to eliminate the complex organic molecules in the exactly which I'm talking about the wastewaters from the different industry clusters. And then there is no power consumption. We can introduce the air blower inside the reactor. So we no need to give external air supplies and then other things, compressed air, nothing. So this is the very important factor. Also, when we're talking about the biological system, it also produced a huge amount of smelly natures when you do the exact wastewater, industrial wastewater. So the technology, but the consumption of power also we calculated just 0.87 kilowatt per hour meter square, while conventional technologies are required 1.4 kilowatt per hour per meter square of wastewater, meter cube of wastewater. Okay, so these things we found some sludge generation in this fluidized bed reactor system. So we incorporated with this material into the fixed bed reactor, so which we developed initially. We developed the lab scale system, for example, 500 ml and then 1 liter and then 15 liter and then 100 liters of wastewater, like a bench scale system. Once we optimized for a long term, like 1 year, 2 year, and then efficiency, we checked the efficiency. After 1 year, 2 year, the efficiency is retained the same as a new. So in that case, we can easily regenerate and then recover the materials. Also, we can utilize for the industrial, direct industrial process. So basically, we developed the biomass-derived carbon-based material, rice husk. We can get from Punjab and then other areas, Haiyan areas. They just burning the rice husk. But in Tamil Nadu, especially Tamil Nadu, they are utilizing for the cow feed, the rice husk, rice bran things. Okay, so it's easily available material, biomass material, especially biomass, and the main concept of the reactor configuration and the reactor system is like to reduce the energy and then sludge generation. This is the main concept of when we design the material. Okay. So also incorporate with this metal oxide, introduce the support. Also immobilize with the biological molecule, for example, biological treatment system. And the system is simple and flexible for the long-term wastewater treatment. So which we developed the system and then we published in Desalination. First article in my research. Okay. So the thing is, we need to understand the complex organics. For example, they have different industries like tannery clusters, textile clusters, also pharmaceutical clusters. They have different organic compounds, the different formulations. So the mix of things, we cannot understand any of the catalyst, what is the mechanism is going on, how the molecule is behaving, also how the molecules, once they break down the molecule, how whether it's toxic or non-toxic, which is very important to control the kinetics. So this one, during my PhD, I take the challenges, for example, simple phenol molecule to the complex system. So variety of molecules, I tried at different aspects. For example, simple phenol molecule, also bisphenol. Also, cyanotoxins is one of the biggest complex organic molecules. Okay, this one we isolated from the lakes. So if you read the recent news from the South Africa, they have around 30 elephants are died due to this drinking in the water from the lake. So because of the lakes, long term they are not used for the water. So it grown the algae. That algae contains the cyanotoxins. That algae, dead cell algae produce dead algae produce cyanotoxins. So that cyanotoxin we isolated from the sewage storage tank. So we isolated the cyanotoxins and we eliminated the cyanotoxins using copper-based material. So this copper-based materials, the design of the pores, carbon nanopores and mesopores is very important factor to control the kinetics. Also, it's very important when you do the reactions, the fragmentation, and then the toxicity of the nature. So we identified the toxicity of nature, which part of the molecule is the toxic, very toxic, and then we used cell line studies, and then this cell line study shows these are the compounds like etoxic, methoxic. These are the compounds. These are the functionalities is responsible for the toxicity nature. So we exactly trying to concentrate on the elimination of nitrogen functionality with bonding with this molecule. So also I tried the diethylphenylene molecule. So which we try to introduce immobilized bacteria immobilized material. So what we did, this organic molecule, we introduced lower concentration initially in the soil. So after introducing 30 days or 20 days, the organism will resist the molecule and it will grow. So the particular organism, which is the organism, we isolated the organism. So we immobilize the particular organism into the carbon matrix. Okay, so that is very important findings. So that that organism, we found the organism matches. So that organism is exactly can utilize the particular organism. Yes, because of the soil, we reduce the molecule, it will grow the organism, means the organism is utilizing the particular organics. So like that, we trial and error, we made many parameters to optimize the conditions. Also, the hydroxy radical is the important factor. So we try to understand the fluorescence property using terephthalic acid as a trapping agent. So we can trap the hydroxy radical. It will convert terephthalic acid into 2-hydroxy terephthalic acid, which we can easily found the fluorescence spectrum. For 25 nanometer, we can get the 2-hydroxy terephthalic acid. When you do only terephthalic acid, there is no fluorescence spectrum. When you have the 2-hydroxy terephthalic acid, there is fluorescence peak in the for 30 nanometers. So emission spectrum and the excitation we can provide around 315 nanometers. So this is very simple method. We can trap the hydroxy radical. When you do the exact trapping method is EPR DMPO studies. So that one we can trap the hydroxy radical because the hydroxy radical is very short life period in the wastewater system. We understood the system using DMPO trapping agents to trap the hydroxy radical, and then we found this 1:2 ratio peak is very important formation of hydroxy radical in any catalytic system using the wastewater treatment process. I was talking about the complex wastewater, which is very difficult to eliminate. So we're trying to eliminate to correct the pH initially, the mixture of wastewater, and then we started electrocatalytic reactors using graphite electrodes and then place the stainless steel reactors. So we connect the cathode anode and then we process the wastewater. But the thing is, very complex system. It consumes powers and then the electrode is corroding during the wastewater because of the salt and then other TDS. It's affect the electrochemical electrode lifetime. So that is very important factor. So we just try to after electrode process, we try to filtration carbon filtration using air blower, and then we introduce the pentam activated carbon catalytic reactors, which we developed the carbon initially. So, and then followed by after treatment, this process, the pH is around neutral. So we can directly introduce to the bacteria immobilized reactor. So we can eliminate the organics present in the wastewater. After that, we can go for the settling tank. And then after settling tank, we can just reuse for drip irrigation, other plant purpose. We cannot use for the direct use for the. So it's very important. So the problem which we faced during the real wastewater. So actually the real wastewater treatment process, it consumes a lot of land for the sequential treatment process. And we cannot avoid the sequential treatment process because we need a lot of sequential treatment process to control the organics in the wastewater. So which is very important. Also the leaching of heavy metals. So it's very huge factor when you do the wastewater treatment because it will also formation of the sludge. The sludge cannot be burnable. When you burn the sludge, it will give the, again, atmospheric pollution. So, and if you do the landfilling, so that will also leach out to the groundwater. So it will definitely migrate to the groundwater and it will pollute the water. Because why I'm telling, in 10 years back, 20 years back, I can able to drink the water from the well or borewell water in my village. So now, currently, I cannot able to drink the water because of the huge salt. That salt is definitely coming from the agricultural use, which we are using the phosphate and then potash and then other fertilizers and then pesticides. It will definitely migrate to the underground and it will contaminate underground wastewater, underground water. So also another things, these all the landfilling, also the storage of wastewater, it also contaminate, migrate to the ground level, it will contaminate to the groundwater. So that's what nowadays the TDS is increasing everywhere, especially Tamil Nadu. I don't know other states in India. Maybe they're also facing the similar kind of problems. So we need to think about the efficiency. The current efficiency is a very important factor when you do the wastewater treatment process. Okay, so another one thing, the catalytic lifetime. So how long it can go? For example, when we developed the catalyst, it can work for 1 year, 2 years, and then we can replace the catalyst. And then when you want to replace the catalyst, what you should do the old existing catalyst. That is an important factor. We need to think about the disposal of the wastewater. So for the disposal, just a simple example, we're trying to dispose after that eliminated the contamination. We try to adopt these materials to incorporate with the Portland cement and then fly ash, and then we incorporate with this binding material, and then we can use as a constructed material or other process. So for example, metal oxides, we can try to coat with this surface of the wall, and then we can make sure the metals are not leaching out to the coated surface. So this is very important fact. So this all we need just knowledge and then just trial and error, just play with this chemistry, surface chemistry. So this is all important when you dispose the sludge. Okay, so now I'm trying to adopt this solar energy utilization recently, just be focusing solar energy. Why we need solar energy? Okay, so for example, if you think about the recent gas, oil, and then coal is depleting. It's very important factor. It's going to expire or it's going to deplete everything in the world. Every researchers are focusing hydrogen fuel. It's very important fuel. There is no carbon dioxide emission due to the hydrogen. It will stream. It will produce only stream when you burn it hydrogen. When you do the carbon-based fuels, that will definitely emit carbon dioxide, carbon monoxide, other toxic gaseous things to the atmosphere. Even, for example, nitrogen, it's NOx. So these all produce the gases. This is again going to pollute the atmosphere. So now every researchers are focusing on solar. Solar is the only existing energy, lot of energy. I can discuss the next slides. So how we can do for the hydrogen and how we can synthesis, produce hydrogen from water and other sources, which I'm going to talk next slides. Okay, actually, solar is the only one renewable source, renewable energy. It's very important things. It produces 20 to 50 terawatt of power in the world. So this power, actually, the power is mainly produced many other aspects like a power plant. Also, because of the power plant, they also emit the carbon dioxide. They also do some things, and then it will produce the complex. So this all the factors influence our environment. So, and people try to do hydropower, also solar power, also wind power. So there are a lot of powers. It's not enough for the old power consumptions. So solar is only the energy source, like 20,000 terawatt of power from the sunlight. So everyone trying to focus how we can utilize the solar power. This is very important point which I'm going to emphasize today. So once the breakthroughs happen, everyone now getting solar energy and then renewable energy. So that is very important in the future generations. We can utilize as a solar fuels and then hydrogen, no carbon footprint and then no green gas emissions, and then we can reduce the atmospheric pollution. So this is very important factors when you do the research, and you can think about how we can get the solar energy to utilize, convert into other energy sources. So how the solar energy, the concept is come. This is, it's not quite new. It's a very ancient things. The plant utilizing the energy, the plant getting the energy from the sunlight and then leave using the chlorophyll is absorbing the carbon dioxide and then water. So it can produce sugar and then oxygen to us. Okay, so the similar concept, nature mimic catalyst artificially. People are trying to get the energy from the water. They can split the water using the material. The material is very important. How you design, how the right material. The right material is very important to produce, to split the water, which I'm going to talk today. So actually, solar energy. Once you design the material, particular material, it's going to happen the breakthrough. So this material, they can connect it to the cathode anode. We can give the less bias, external bias, and it can split the water and then have oxygen. We can store in the storage tank. So this is going to happen in the future. Okay, so we can utilize this hydrogen fuel for other purpose or vehicle purpose. We can store or we can convert in the electricity to generate electricity and it as a fuel, solar fuels. Okay, so we just optimize this system, small scale laboratory system, using the solar light, simulated solar light, and we produced just very few micromoles using just pure water without using any sacrification. So this one, the material design. The material design concept is we need to understand material properties. For example, if you want to split the water, we need to match their potentials, the material potentials, exactly fitted onto the water, and then water splitting to produce hydrogen. And then when you split, when you convert in the carbon dioxide into other fuel chemicals, we need to fit the redox potentials of these materials. We need to design, we need to engineer the material, we need to tailor the material. So this is the key factor to optimize the materials and then to bring down the right material to convert the solar energy, which is very important factor. Recently, I reviewed these nature papers. Everyone focusing, copper is excellent material, but the thing is, it's stability. is a very important factor. So it's not stable when you do the reactions. So how we can protect the stability, how we can control the stability to introduce new code catalyst or protecting the carbon layers. These all are the factors to bring the right materials in the future directions. Okay. So nano engineering. So nano engineering is a very important factor to how morphology is affecting the catalytic activity. Also surface, how the surface is behaving, the surface changes before and after catalytic natures. These all are the factors, defects, how you can create the defect. Because when you do the sunlight reactions, the copper ability or any metal oxide or other things ability can recombine the electron on the hole, which is crucial factor. So volume recombination inside. So also another factors, it will recombine on the surface. So this both is the major impact on the catalytic system. So we need to control the system to avoid the recombination. This is the important things, how you design the material. Even I try to got even quality of structure, which is not very good active in the solar light. Because the structure looks quite, you can see the structures are very, looks beautiful, but it cannot harvest the energy because it is already recombined, surface and other volume recombinations. So we need to tailor the materials. For example, we try to understand different sizes during my studies, in postdoctoral studies. So I try to find this. Size is the matter. So I try to understand different sizes of the copper oxide material, for example, cubes. I try to increase the cubes, reduce the size, everything. Just modulation, just play with the chemistry. So in this one, we found the hydrogen production in the pure water, which is few micromole, 0.0013 micromole per gram per minute. So, and the quantum efficiency is just 1.2%. Okay. So, which we trying to improve this quantum efficiency also to increase the hydrogen production rate. We introduced hierarchical materials. So in these hierarchical materials, this smaller size accumulated with these bigger molecules. So it can absorb the solar light, and it can absorb the energy, solar energy, and it can produce the hydrogens. The hierarchical materials can produce hydrogen from 18 micromole to 31 micromole when you protecting layer with the graphene oxide. So which we trying to introduce the graphene oxide, different concentration of oxides property, and then we understand the light harvesting property. We connect with this electrode. We made the electrodes coated with the copper oxide on the electrode surface, glassy carbon electrode surface, and then we introduce the light, and then we check the efficiency, current efficiency. The photocurrent density is increased when you incorporate with this graphene oxides. Also charge carrier densities, which also improved when you introduce the graphene oxide. So we found before and after catalytic reactions, the copper stability is excellent compared with the pure copper oxides. So if you see this 18 micromole, we produce 18 micromole here to improve from 0.13 to 18 micromoles, which is very high compared with this to design the materials. Okay. So the quantum efficiency also we increased 1.2 to 2.2, which we recently published ChemCat Chem journals. You can see this paper, so easily you can understand how the designing properties. Okay, so after that, the only copper is unstable, or we can introduce the protecting layer. So what we did here, we designed inside copper 0, inside the particle copper 0, on the top copper 1 plus, on the top copper 2 plus, like the core shell structures. So the core shell structures can protect the copper 1 plus oxidation, which we proved during the synthesis. And even this all the things, there is correlations. Here we used polyethylene glycol, which is not good for to control the size and structures. So polyethylene glycol, we need to eliminate the polyethylene glycol after synthesis process. So also the ethylene glycol properties, it can control the light harvesting property, which is not good for using polymeric material. In this one also we used polymeric material. In this one, we trying to eliminate the polymeric materials or templates. Okay, so these are the important factors, other chapters. And we understand this material property across the particle. What is the composition of 1 plus 2 plus? This we used for yields, electron energy loss spectroscopy from the TEM. We can understand the 1 plus 2 plus oxidation. But also we understand the bulk nature by X-ray near adjacent X-ray near adjacent edge spectra, which is available in only 44 mesh instrument available in the world. Okay, so which is one of the instrument, one of the beamline we are using to understand the properties of the material. So this material actually we utilized for just paracetamol. We consume the paracetamol as for example, headache or fever. We consume the paracetamol. Especially why I chosen the molecule is mainly consumed for UK, United Kingdom as well as Japan. So I chosen the molecule, and then we understand the molecule fragmentation. What are the fragmented molecule is forming during this system. So another one important factors we found, interestingly, just HPLC method we optimized to from the OH radical productions. So pure formaldehyde, there is we cannot get any HPLC peak, but when you okay, so pure DMSO cannot get HPLC peak. So formaldehyde can get OH radicals. So when you do the light-driven reactions with formation of OH radical, it can react with DMSO. It will produce the formaldehyde. So the formaldehyde can incorporate with this dinitrophenyl hydrazine molecule. So we can check the HPLC. We can get the peaks, elevated peaks, which we initially we introduced this concept. I think is a new for the photocatalytic system. So just HPLC we can confirm the production of hydroxy radicals. Okay, so another one factor, designing, which I'm talking about using the surfactant. Okay, initially we used surfactant to produce the control structure, but in this one we eliminate the surfactant. There is no surfactant used for these methods to produce a particular sequence nice structures. So we have not used any surfactant, no templates, no structure directing agent, but we control the structures using kinetically. Means we just play the conditions, optimize the conditions, either reducing agent or reducing the precursors or mixing the ratio. So everything play important factors to control the structures. So finally, we understood these controllable structures. The size is the matter for harvesting property, light harvesting property, which we recently published in Applied Cat B. You can see the papers. Okay, another important factors. So the same size control, we're trying to eliminate the polymeric material. Also, we need to incorporate with this fiberic material. So it can have PN junction. It can play major role to control the copper oxide conversion, 1 plus to 2 plus conversions. Also, it's an important factor when we do the without using fiber structures. The structures can grow around 300 to 400 nanometer sizes. But when you use the fiber materials here, you can clearly see that size can be controlled using the fibers. So when you give the fiber structures, so the growth, crystal growth is controlled by the fibers. Okay, so the size is grown, the particle size is 100 to 60 to 100 nanometer sizes. It will interpenetrate PN junctions, which we proved copper-copper bonding, also copper-titanium bonding from the X-ray absorption, near absorption spectroscopy, basically synchrotron technique. Okay, and also we confirmed the TIM, the despacing, the interconnected despacing from the copper one and titanium bonding. So we can clearly see the EDAX mapping. Copper, here you can see the copper oxide and titanium oxide, how they bonded with this fiber and then copper. So which is important to produce hydrogen. You can see here from 0.01 micromole to 48 micromole, we improved a lot. And then the quantum efficiency, apparent quantum efficiency is excellently improved from the first cubes to in this cube. Okay, so this is the way we need to construct the material, how we are designing. So another one point I want to emphasize here today. So we recently proved the concept. Everyone talking about electron flowing. Electron is the very important factor for redox reactions. Okay, so how much electron reacted? How much? This is quantification. How much electron reacted? Where is the electrons? Where is the conduction band or bottom position or valency band? So this is all important factor. When you irradiate with the light, so the electron will flow through valency band to conduction. So the first proof concept we recently developed this one. So this methanol saturated cell, okay, we can introduce your powder material. So methanol saturated under nitrogen atmosphere, closed reactor. We can connect with this microphone. Okay, so when we irradiate with the light, solar light, we used modulated light and simulated light. One is continuous and one is modulated light, two lights. So the electron can exit. Okay, so the exited electron connect with this microphone, can detect, and then we connected with the amplifier. So the amplifier can detect how much electron, and we, based on the physical chemistry theory, we can quantify how much electron is involved, which place exactly near conduction bottom. So this is, we just recently proved chemical communications and then ACS applied material. We can see this work. Also we are trying to control the size, porosity, carbonization material using templates, silica template, also mesoporous carbon nitrides to control the ball, hierarchy ball, rod hierarchy. So also controlling the tube-like, hollow tube-like, porous hollow tube-like for energy, especially energy applications. So these are the some sizes which I controlled and then effectively incorporate with this metal oxide and other particles and porous structures. So just designing using simple methods, calcination, surfactant, polymer assisted photoredox methods, sustainable approach. So all the approaches we developed these methods. So the summary, I don't tell the summaries exactly. I give the message, which is very important to manage, how we can manage, how we can control globally. Okay. Experimental, environmental waste or household waste, anything. Okay, basically we need to separate. I'm telling we don't have proper management. Just we can manage. When we manage, we can control we can preserve our environment. Really, so this is very important. We can learn from the different atmosphere, different experience. So just I taken the pictures from my last previous university. They have separated bottles separately, PET bottles. Also bottle cap, they separated. They can reuse the bottles and then they can reuse the bottle caps. That is different polymeric natures. So what they do, trying to do, they eliminate burnable garbages. So for example, household garbages, we can separate household garbages and we can convert as a manure. So we can use the manure for our plant purpose. So also they used for toxic waste separately, different acids separately, solvents separately. Also radioactive elements separately. For example, heavy metals, different heavy metals have different characteristics. So they separate all the elements, and then we can easily do control, and then we easily recover, or we can easily dispose. This is very important when I learned from these separations. So when we separate these things, we can definitely protect our environment. We can preserve for our indigenous. We can give which we are living the same environment we can give our young generations. So the young generations are very important for us to maintain the quality environment. So actually, these are some technologies which we transferred from during my PhD time at Reddy's lab, and then chemical industry, Dubai, Sri Lanka, and then Reliance Petrochemical, Maladi Drugs. So, and also Aarti Chemicals from Vapi, Gujarat area. Also CS Specialty, maybe it's from Pune. And then also we given Tamil Nadu Newsprint Limited, Arcade Limited. So these are the AstraZeneca as well. So these are the technologies which we transferred. When you do the research, when you see the pictures, real pictures, so you can be proud, or you can be like, we can feel the things. Oh, okay, which we achieved something, but I'm not achieved anything at the moment. So I have some message. Actually, when you really want to do something, if you don't have any source or don't get any experience, now you have everything in your hand, source. So the search engines, Google proposal, okay? But the search engines can tell anything where you want to go. You just set your goal first, and then dream your focus. That is very important thing. Every day, the dream will wake you up to do work. So when you started work, you started any work that will impact on your futures, impact on your impact on your society, and step up your dream. There is a lot of ups and downs in your way. There will be many huge obstacles, and then surroundings will influence you or pull down. But this is just do your dreams, your goal. Okay, acquire knowledge continuously. Even you are getting benefit, not getting benefit at the moment, doesn't matter. So just continuously acquire knowledge and hard work your dreams. Okay, take risk. Risk is the important factor. So if you think this is my comfort zone, I don't want to go anywhere, that is not good. If you think take risk, if you take risk, definitely you will fall down and then wake you up again. Just another fall down, wake you up. So you will get a lot of experience, and then you will achieve something definitely. And then fight until you reach your goal. So this is my message, not my message. It's a very old message. Everyone maybe knows, or I'm just recalling this. Okay? So when you do the different cultures, you can meet a lot of peoples. You can get knowledge from them. You can share, definitely they can share their knowledge, how they grown. Even this Randy Sexman, recently we met, he's a Nobel laureate. Recently we met, he shared because of his students in power, he achieved like that. He was saying now he's not getting funding like that. He was discussing a lot of things. So when you move this around the situation, so you will get different knowledges, and you also get knowledge from the search engines. Okay, use search engines and then get knowledge and then get experience and then move around the world. Okay, so this is my PhD group, and then this is my Newton Aston University UK group. This is my boss, Aaron Lee, Karen Wilson. This is my last previous group, JSPS group. I was there. If you know more about me, you can see this barcode, and then you can see my studies and my everything using this barcode. Okay, so of course, I want to thank you for the management committee and then director principal, AICAS, and especially Dr. K. Ravi Kumar. So he's one of my friends from 10 years. Special thanks to organizing committee. They're really doing great. And thanks for the audience. It's very important to listening whatever the shit things I'm talking about. So thank you very much for everyone.
Thank you so much, sir. Thank you so much for your wonderful lecture. This has really helped us. First of all, I would like to thank for the motivational speech which you were given at the beginning of the session. You talked about those who are coming from the Tamil background and in the village background. Still, in Tamil Nadu, in many participants, they are from the village background and they are could not afford English easily. So your talk will give the stimulation and make some enthusiastic approach to all the participants. I hope this will stimulate all the participants to do the next level. And the last session also you give some points, last slide. That is also motivate us and motivate the research scholars, students to do their next level. This may be helpful for achieve their goal. Thank you so much, sir. Really, we impressed from your lecture. Thank you for that. Before going to the questioning session, we have one more information to the participants. Those who are not yet presented oral presentation yesterday, be ready for the presentation. After the question session is over, you will present your oral presentation. I just list out the names. Those who are be ready for that. First, Dr. Divya Velpula. Second, Srisha. Third, R. Radhika. Fourth, H.R. Pradeep. Fifth, M. Ramudai. And finally, Tilaka from SRN College. All the participants, I request you be ready for the oral presentation after the question session is over. Okay. Okay, thank you. This is the time for the question session. I request all the participants to reciprocate with our honorable chief guest with your valuable questions, suggestions, or your compliments. Anything you can ask our chief guest, he will answer you.
Thank you for the opportunities. And you can ask any questions, even if you are wondering about the language. You can ask
Yes,
Tamil.
sir.
I can
Yes.
answer anything. So I'm happy to answer. Yeah.
Yes, sir. I'm belongs to English department, sir. But even I myself, I came from Tamil background. Even the village, I couldn't afford English in the big the participants. I request you, if you have any doubt, any clarification, any questions, you can ask the chief guest. Or you can put it in the, sir, please, I request you check in the chat box. Is there any questions? You can answer to them, sir.
The participants can unmute their microphone and ask the question directly.
Okay, participants, if you have any questions, you can ask him. Otherwise, we will wind up the session. Then we will move to the oral presentation. And one more information in the chat box, we send you the feedback form link. You can fill it the feedback. சார் கேளுங்க சார். சார் கேளுங்க சார், ஆடியோல கேளுங்க.
Hello, sir.
Yes.
This is Shugati from SRM, sir. SRM
Yes.
Institute.
Yes.
Sir, actually, you have done JSPS fellowship also, right?
Yes. Yes.
Actually, I have doubt about that. Like, at what basis they are selecting? It's beyond this presentation, but I have doubt with that.
Okay. So actually, it depends on your work quality. What is your work you are doing? What is environmental impact? So how your work is going to impact on the society. So when you target your the quality of work or something, so you have quality of even publication also impact on you. The publication doesn't matter if you have 6 or 7, even 7 publications people have got JSPS.
Okay, sir.
Work, what is your work and how you, like example, like out research programs, if you do something for school kids or something, so you can put in your CV and then you can showcase like I did this, and then I deliver these thoughts and then I deliver my work to the society. So like that you can try to adopt everyone. Like, yeah. So when you do this all for not only JSPS, every fellowships, your work is really impact on society. That is a very important factor. Also, your proposal, it's just 2-page proposal. You just make sure how is going to impact on society and should be reliable and should be proof concept proposal. This will be success. Definitely you will be getting success.
Okay, sir. Actually, there is some saying like Japanese and Korean will consider like instrument basis work.
No, that doesn't matter. Actually, doesn't matter. Don't think. Even when I applied in Newton Fellowship, I don't have any quality publications. That time I have only the like catalysis science and tech, the best paper. So it's, I cannot say that is best paper. It's based on the quality of work which we transfer the technologies from the industry. So that is also important. So trying to do something small, even small scale also fine, to deliver the societal, for example, remove viruses from the wastewater, or eliminate the virus. So that is important now the society is facing the problem. So you can try to adopt that kind of things and then you just think broad way of your research, not only focus narrow.
Yes.
So important thing.
But frankly, I can say like nowadays people mostly focusing on publications. Like
Actually, it doesn't
some
matter.
people
Doesn't matter. Even I know few people's got without having any 10 more than 10 publications. Okay, just 5 publications they got it. That means that proposal, quality proposal, and then how they showcase your out research programs. That is also important. You can go and give the lecturers to even your small schools. You can share your knowledge that you can put your CV. Just make your CV more competent.
Okay, sir. Thank you, sir. But actually, you are doing with the CO2, right? Copper oxide, right?
Yes.
But titanium dioxide is the best material for catalysis now. Till now.
Yes.
But
Actually,
how come you are, how you are justifying that copper oxide is like
yes,
in this application? Yeah.
Actually, when you do copper oxide, that is actually earth abundant material. Another one more thing, when you do titanium, it's like a colloidal thing. So it's very challenging to recover. I'm trying to now trying to make a film kind of material, like a organic inorganic hybrid. So that material can be used for real industry wastewater. So that one we are focusing. Actually, copper is a very good material. So if you see the nature papers, the recent nature papers, okay,
Yeah, it is very good materials. And nowadays, people
actually
focusing on copper-based materials.
another one more thing, it can harvest the UV to near higher range when you make the modulations. So even now, you know, copper 3, okay, copper 3 plus one of my group, the previous research institute, they found the copper 3 plus state oxide. So
Okay.
like that, we need to design the material. So everything available, how you design the material, so how you are complex with this material. So important factor to control the copper corrosion. Okay, copper
Okay.
1 plus to 2 plus oxidation. 1 plus is actually exactly right material. You can choose the material.
Okay.
But
One
the thing
plus.
is, very photocorrosive and easily can convert even oxygen atmosphere, convert into 2 plus or yeah. So this is very important how you preserve the 1 plus state. For
Okay.
example, coordination, complexation, or making the polymeric material, hybridization. So these all important factors to control the crop.
Okay, sir. Actually, so what about silver? Like,
Yes,
it has a anti-corrosive property, but when I doing CV measurement, I have faced corrosive like it corrode the FTO in
yes,
electrolyte.
yes.
So what is the reason behind that? Since it has anti-corrosive property.
Actually, I would suggest silver is a very good material, even antibacterial property, anti-corrosive, anti-coatings. Okay, so but the chosen silver is nowadays the price of the silver is going higher than gold. Okay,
Okay.
not India, actually in
Yes.
everywhere, silver is going high. So I would suggest anyone they're thinking they don't want to use for silver. Even copper is better than silver activity. Even that copper is going to antibacterial materials. So they're trying to do copper-based material. In
Okay.
that case, I because I never worked silver, so I could not able to tell what is the problem you are facing actually. So if I work something, I can express something. What is the real problem?
Okay.
Maybe I guess silver is changing their oxidation property, so that's why it's corroding, or it can absorb atmospheric. What condition you are doing actually? Which condition?
Room temperature, sir. Room temperature only.
The pressure, the oxygen atmosphere or nitrogen atmosphere?
No, sir. Actually, I'm doing CV measurement, cyclic
Ah,
voltammetric measurement.
yes, you
Uh,
closed. CV also we can close, you know, right? The
yeah, closed only, sir.
closed on, and then you purge nitrogen or no?
No, sir. No nitrogen at all.
Maybe try to purge nitrogen 30 minutes in
Okay.
the CV cell. Okay, what is the electrolyte you are using?
Iodide electrolyte, sir.
Okay, so try to purge the nitrogen and then do
Okay.
your close and then do your CV. Maybe try to understand is that really corroding or not corroding when you do the nitrogen.
Oh, okay, sir.
That maybe will influence. You are doing XRM, right? Right now?
Yeah, SRM only, sir. In
SRM
SRM.
IST. To whom you are working?
I'm working under Dr. G. Bakiraj.
Okay.
But I'm also working in Dr. Navanithan sir lab.
Yes. Okay, that's good.
You have heard about him.
Yes, I know.
Yeah, I'm
Okay,
working in his lab. So
okay, that's good.
yeah, thank you, sir. So okay, thank you, sir. Thank you.
Thank you.
Yes, sir.
Thank you for the nice interaction with the sir. Any other questions from the participants? So I think some questions in the chat box.
Actually, they're suggesting something like KOH can use. Also, sodium sulfite can be useful for another electrolyte. Yeah, which we try to use. Yeah, the pH matter for the corrosion. Yes, they said iodine is corrode. Yes, maybe. Yes,
Sir, actually, iodine will corrode the material.
yes,
So
yes.
even madam will do in acidic environment also, there will be problem with the conversion of silver to silver ion.
Uh,
Also a problem. So it's better to do in a neutral media or in a basic media for corrosion study.
yes,
Divya Vepla, sir.
electrolyte. Maybe electrolytes. Maybe.
Yeah, electrolyte will play a crucial role because to study corrosion rather than the material, electrolyte will play a crucial role.
Yes, yes. True. It's true.
Yes, sir.
Thank you, ma'am.
Thank you, ma'am. Thank you.
So please raise your hand or questions. I'm happy to support anything, even basic. Doesn't matter. If you
Sir,
hesitate-
one question from a chat box.
Okay.
That is the which are material science field directly connected to day life. That's the
Actually,
question. Yeah.
it's interesting. Actually, every field actually connecting to interconnection, biological, physics, mathematics, everything interconnected. So we cannot say exactly which field is directly connected to the day-to-day life. Every field is very important. We have to connect and we have to work interdisciplinary, not only one discipline. I'm focusing this material. I can work this material or I just protect the environment, nothing. So we need to play all biological system and the environment, so chemist, physics, mathematics, all important to connect the day-to-day life.
Yes, sir. Sir, one more question, sir. So when we are passing the UV light through the water, some
Yes.
bacteria is killed. What
Yes.
about the good bacteria?
Actually, when we do
In the term of RO process like that.
okay, so your question, okay, so you want to control only the negative bacteria, not only the positive
Yes,
bacteria.
yes, yes, sir.
So if you want to do UV or something, definitely produce hydroxy radical in your system, whatever the system you use, because that is UV strong light. So it definitely kill all organisms. So you cannot get all the organisms. Even the another one point I want to emphasize here, when you do RO system, okay, so there was big challenge. You cannot get all minerals because RO can reject all the salts. So what even including the good minerals. So we cannot get a zinc, calcium, iron. So in that case, bacteria definitely kill. So you cannot get good bacteria in the UV system.
Okay, thank you, sir.
So in the mineral water system, I would suggest RO. Okay, so RO is good actually, but to control other salts, other bacteria. But thing is, you will not get a mineral. So you have to take externally minerals like zinc, calcium. It's very important. Iron. These all important. So in all the countries like developed countries, they used to take calcium, vitamin, calcium tablet, zinc tablet, iron tablet. Even in India also they given tablets. Right? When we go the problem with like a bone or something. So that time they definitely given the calcium iron tablets. So I would suggest you take calcium when you drink the RO water. So you consume the iron, calcium, some zinc vitamins, also vitamin D, very important for the bone.
Okay, sir. Thank you, sir.
Okay, thank you, sir. Nice interaction. Participant, any other questions you can ask? Any questions? Okay. Thank you so much, sir, for sparing your valuable time with us more than 1 hour. Because even in a busy schedule, you are sparing your time with us. Thank you for that. Thank you for enlightening us. Thank you so much, sir. Thank you.
Thank you. All the best for the conference successfully.
Thank you. Thank you so
All
much.
the best for all the participants. Do your best. Thank you.
Thank you. Thank you, sir. Okay. Thank you. Now the session is for oral presentation. Before starting the oral presentation, I remain the remaining 6 participants. Be ready. You can remember there is a small instruction for you.
Sir.
Okay. 5 minutes for each presentation. So because yesterday also we have lot of time. So you be consume your time. Okay. Okay, just I'll call you slot number, then you can come and present. Okay. First, I'd like to call upon the first oral presenter, Divya Velpula, slot number 14, women scientist from Hyderabad.
Good morning, sir. Can you hear me, sir? Hello.
Yes, ma'am.
Yes, ma'am, is audible.
Sir, can you hear me? Can you see the slide, sir?
Yes, ma'am.
Yes, ma'am.
Thank you very much, sir. Good morning, one and all. I'm Dr. Divya Velpula, working as women scientist in Center for Nanoscience and Technology, IST, JNTU, Hyderabad. Today, I'm going to present one of my research topic, that is biosensor polymer nanocomposites. First of all, I would like to thank the organizing committee for accepting my abstract for the oral presentation. Thank you very much, sir. So coming to the outline, here I'll start with the introduction, followed by experimental section, then result and discussion. Finally, I'll end up in my topic with the summary. Coming to the introduction, metal polymer nanocomposites are nothing but they are formed by combination of metals and polymers in which either one of them has to be in nanoscale dimension. So why we need to add metal to the polymer or polymer to the metal? Because with this addition, metal as well as polymer get benefited. So what is the benefit? If I'm adding metal to the polymer moiety, the surface area of the metal will be enhanced. So if the surface area of the metal will be enhanced, then it will improve their applications in biosensing and electrocatalytic ability. So what about the polymer? When I'm adding metal to the polymer moiety, then thermal stability will be enhanced. So along with that, conductivity, electrical conductivity also improved. So here I chose silver polyindole as my composite. So why I chose silver polyindole? Because silver and polyindole will have good ability, or they are having bioactivity towards various biomolecule. And it is very easy to synthesize silver nanoparticle, but it is a challenging task to synthesize polyindole because of its low polymerization efficiency. So we need around like a higher pressure or lower temperature to synthesize polyindole, about minus 23 degrees centigrade, and there will be some crucial conditions required. So what I would like to do, I would like to make the system simple. So I can use either redox potentials of a metal or redox potential of a polymer, or I can compare standard electrode potentials of these two materials, or I can go with some system which supports the formation of polymer nanocomposite. So here I use liquid-liquid interfacial methodology to synthesize my silver polyindole composite. And there are various methods to synthesize metal polymer composite using liquid-liquid interfacial methodology. Those are simultaneous redox reaction, or incorporation of metal into polymer moiety, or some electrochemical approach. So among these approaches, simultaneous redox reaction is very simple one. So here I labeled orange one, you can see here. So we need to take a metal precursor in the aqueous phase and monomer in the organic phase. Due to redox reaction, there will be formation of metal polymer composite at the interface. So why it is forming at the interface? Because interface always suffers from interfacial tension. So it always wants to reduce the interfacial tension. So it would like to agglomerate the particles at the interface. Then the interfacial tension will be reduced. Further, I use silver polyindole composite to reduce the interfacial tension. So because of that interfacial tension, there will be formation of silver polyindole composite at the interface. And my composite, I would like to go for sensing of dopamine because dopamine play a crucial role in central nervous system. And it has direct relation with the habits, learning ability, motivation skills. So abnormal level of dopamine create various problems in which one of them is Parkinson disease. So it is very important to detect dopamine in low concentration level. And we have various methods for detection of dopamine at low concentration level. Till now, up to that, we have a method which can go for low concentration, that is electrochemical approach. And they went for 300 nanomolar detection of dopamine. But I would like to detect my compound dopamine with lower concentration than 300 nanomolar. So I use a simple technique, cost-effective method, as well as it is very accurate. How many times we'll get accurate result, that is fluorescence spectroscopy method. So why I use fluorescence spectroscopy method is polyindole composites are fluorescent. And if I'm adding silver to the polyindole, the fluorescence ability will enhance. So by using that, I can detect my compound in nanomolar ratio detection. So this is a synthetic methodology. As I mentioned earlier, in aqueous phase, I took metal precursor, and in organic phase, dichloromethane, I took monomer of indole. As time proceeds, there will be formation of metal polymer composite at the interface. And in this, the reaction mechanism follows like this. Silver oxide acts as oxidizing agent, and this oxidizes indole to polyindole, which follow radical cation mechanism, addition of radical cations. And we should remember that we observe this is 2,3 coupled polyindole because nitrogen, after nitrogen, that is 2 coupled carbon and 3 coupled carbon that confirmed from FTIR spectroscopy. So from the FTIR spectroscopy, we concluded that we formed silver polyindole composite, and we compared the result with the polyindole synthesized in a similar protocol. So here, the peak at 721 and 776 are absent. That reflect this is the formation of 2,3 coupled polyindole, as C2H and C3H protons are absent. I label here polyindole with a red dot at the bottom after 5, beside 5. So I confirmed the formation of silver polyindole composite. And I should know that silver has to be present in the polymer moiety. That can be confirmed from XRD spectroscopy. So from XRD, I concluded that there will be formation of FCC crystalline silver nanoparticle over the polymer moiety. The inside depict polyindole. And then I went for SEM analysis. So in SEM analysis, what I observed, there is a nice dispersion of silver nanoparticle above the polymer microfiber. So I can confirm that there will be formation of silver polyindole composite from SEM, and EDAX also supporting that. And I took STEM and EDAX of my silver polyindole composite. After that, I did UV visible spectroscopy. That is also supporting the formation of silver polyindole nanocomposite. And it is very important that my silver polyindole composite have higher thermal stability than polyindole, which is synthesized in a similar protocol. So this is very good for various applications. Then I went for Raman spectroscopy. So in Raman spectroscopy, it is showing that the Raman intensity of silver polyindole composite is higher than that of the polyindole. So this is also giving an additional benefit, and this is due to synergetic effect of silver particle over polymer moiety. And we observe various bands I depicted at the bottom of the figure caption. And as I mentioned, silver polyindole is having fluorescence property, and silver polyindole is also showing higher fluorescence property due to their like surface plasma resonance ability. So this is a fluorescence spectra of silver polyindole composite as well as polyindole. Here I observe higher intensity of silver polyindole nanocomposite. So if the intensity is higher, then the detection limit will go down. So this is very good for my biosensing application. So I went for the application to detect dopamine. I added various concentrations of dopamine. So with the increasing concentration, the peak intensity decreases. So this decrease in peak intensity reflects there will be interaction between dopamine as well as silver polyindole composite. So by using fluorescence spectroscopy, I can be able to detect up to 40 nanomolar detection limit. And these are calibration curves, which shows the ability of silver polyindole composite in detection of dopamine. So why it is detecting? Because the absorption spectrum of dopamine, that is biomolecule, will overlap with the emission spectrum of silver polyindole composite. So this causes detection of dopamine by silver polyindole composite, which follows Foster energy transfer mechanism. So here silver polyindole acts as donor and our dopamine acts as acceptor. This leads to the detection of dopamine in low concentration level. Coming to the summary, here we synthesize silver polyindole composite using water dichloromethane interface, which is very simple one. And the silver nanoparticle exhibit FCC crystalline structures. It is exhibiting violet fluorescence and it is having large thermal stability, fluorescent stability also compared to that of polyindole. And we can able to detect nanomolar concentration of dopamine, which is very good compared to earlier literature using a simple silver polyindole nanocomposite system. I would like to acknowledge my professor, PhD professor M.V. Senganarayan sir, IIT Madras, Chennai, India, Tamil Nadu. And I would like to thank Dr. Shilpa Chakra, Assistant Professor, CNST, IST, JNTU, Hyderabad. And I would like to thank SERB for funding. Thank you very much, sir.
Thank you so much, ma'am. Nice presentation.
Thank you, sir.
Thank you. First, I would like to welcome our chairpersons, Dr. M. Balaji, Assistant Professor from Bannari Amman Institute of Technology, and Dr. K. Shakti Pandi, Assistant Professor, Sethi Institute of Technology. So, is there any questions from chairpersons you can ask her?
Okay, sir. It was nice presentation, ma'am. You are using you are using silver metals, isn't it? Silver,
Yes, sir.
polyindole.
Yes, sir.
Instead of silver, have you tried any other metals?
Yes, sir. Actually, silver standard reduction potential is about 0.8, sir. And copper, I would like to use copper, but that is less than polyindole. So to form polyindole, it has to overlap the standard reduction potential. So
Okay,
I use silver rather than copper. And silver will have good bioactivity compared to that of other material. Copper than silver. That's why I use silver polyindole, sir.
Okay, ma'am. Okay.
Yes.
Okay, ma'am. Thank you.
Okay, thank you. Thank you for the nice introduction. Next, I have to call upon the next participants. Srisha, slot number 18, research scholar from Jawaharlal Nehru Technological University, Hyderabad. Srisha.
Good afternoon, sir.
No.
Good afternoon. Please proceed.
Yes, sir.
Hello. Your voice is not clear.
I'm sharing the screen, sir. One.
No, your screen is not also not visible. No.
Can you see my slides, sir?
Yes, madam. It is visible now.
Okay, thank you, sir. Good afternoon, everyone. I'm Sirisha from JNTU University, Hyderabad. I'm working as a research scholar for DST SEED project under the guidance of Dr. C.S. Shilpa Chakra, ma'am. Coming to my title of presentation is Supercapacitor Application of Nickel Magnesium Hydroxide and Nickel Magnesium Hydroxide with RGO Nanocomposite as electrode materials prepared by co-precipitation technique. These are the contents of my presentation. Current research and development have been mainly focused on energy storage devices that is batteries, lithium-ion batteries, supercapacitors, and other related batteries. Compared to the batteries, supercapacitors possess higher power density, longer cyclic stability, and higher efficiency. These supercapacitors are also known as ultracapacitors, which is having high capacitance compared to the other capacitors. This plot is known as Ragone plot, which will compare the various energy storage devices by plotting energy density versus power density. Basic design of supercapacitor consists of two electrodes separated by a separator and an electrolyte which electrically connecting both electrodes. Supercapacitor's working principle has two mechanisms. One is charged mechanism and discharged mechanism. In the charged mechanism, in the electrolyte solution, both positive ions and negative ions will be there.
Srisa,
Sir.
Srisa, can
Sir.
you hear me?
Yes, sir. Yes, sir.
Please make it full screen mode.
Okay.
You have no issues. Come to your result and discussion part. No need to explain this.
But title is visible, sir.
Yeah, visible. You can proceed from result and discussion part.
Okay. Sorry. We have synthesized nickel magnesium hydroxide and nickel magnesium hydroxide with RGO composites by co-precipitation method. We have taken nickel and magnesium sources in the distilled water, stilled well to get a clear solution, and after by maintaining the temperature at 80 degrees centigrade. After that, we have added a few drops of ammonium hydroxide to get a pH of 7. From this, after stirring for 2 hours, we got a precipitation that is NiMgOH. Same procedure we have repeated for various weight percentages of RGO, that is 0.5%, 1%, and 1.5%. By following this procedure, we have prepared 4 samples, that is bare NiMgOH and with RGO nanocomposites 3. We have named it as NMNH, NMNH1, NMNH2, and NMNH3. Coming to the powder XRD was used to characterize the prepared nanomaterials. The peaks are showing the presence of nickel hydroxide, magnesium hydroxide, and RGO. Here we can observe that the concentration of RGO is increasing, the peak intensity of RGO is increasing. We have calculated the crystallite size by using the Debye-Scherrer formula, and the PSA technique was performed on the prepared nanomaterials to understand the uniform distribution of the nanomaterials. The average particle size is in the range of 1 to 100 nanometer only, which the crystallite size and particle size values are tabulated in the above table. The absorption spectra were recorded in the range of 200 to 500 nanometers. The absorption peak at 232 nanometers corresponds to the RGO, and around 350 nanometers corresponds to the presence of nickel hydroxide, and the around 230 nanometer corresponding to the magnesium hydroxide. From the FTIR spectra, the bands are showing the presence of nickel hydroxide at 3451 per centimeter, and magnesium hydroxide at 1450 per centimeter, and RGO is at 2069 per centimeter, and functional groups are C11C, C11O showing respective bands. The cyclic voltammetry studies were performed by using a 3 electrode system with a potential ranging from -0.2 to 0.6 voltage, with increasing scan rates of 2 millivolt per second to 100 millivolt per second. The area under the voltammogram increases with increase in the scan rate, which means it indicates high power characteristics. We have calculated specific capacitance and energy density values from using these formulas. If we can see in the table, for bare NMNH, we got specific capacitance at 2 millivolt per second is 270.93. Here we can observe that for 0.5% RGO, it is showing 387, and 1% RGO 418, and 1.5% RGO 459, which means here RGO, by adding RGO, it is enhancing the capacitive behavior of the prepared NiMgOH material. Galvano's charge discharge measurements at a potential time frame at constant current value give the charge storage of the electrode. The curves are showing good capacitive electrochemical reversibility, showing a typical triangular wave. In a black one, NM a bare one. With an increasing in the RGO, there is a trend observed that increasing in the discharge time. The capacitance calculated from the using this formula. Here also it is observed that increasing the RGO percentages, there is increase in the specific capacitance. From the EIS data, we can observe that straight line at the low frequency region indicates the rapid ion diffusion in the electrolyte towards the electrode, and the depressed semicircle in the high frequency region indicates the lower charge interfacial phenomena. By this, it is a dual contributing charge transfer phenomena. The applications from these results, it will be applicable in power source for laptops, flash in cameras, and in other electronic devices. It will also used for power systems in the missiles, in automobiles as a voltage stabilizer also. Coming to conclusion, the chemical co-precipitation method was used for the preparation of nickel magnesium hydroxide and with the RGO nanocomposites. The XRD and FTR studies were showing the presence of nickel hydroxide and magnesium hydroxide, all the materials in the composites, which mean the specific capacitance calculated from cyclic voltammetry and the GCD curves showing good capacitive behavior. The higher the specific capacitance from cyclic voltammetry occurred 459.06 farad per gram to 2 millivolt per second scan rate, and energy density occurred 40.80 watt hour per kg for NiMgOH, 1.5% RGO. As the concentration of RGO is increasing from 0.5% to 1.5%, the specific capacity and energy density values were increased. This confirms the hybridization of RGO with NiMgOH. This will improve the conductivity. I would like to express my sincere thanks to PI, DST Seed project for consistent guidance and encouragement. Thanks to the Department of Center for Nanoscience and Technology. Thanks to the Director IST, and thanks to the Jawaharlal Nehru Technological University, Hyderabad. I would like to acknowledge DST Seed for providing this fellowship. And thank you to Vivekananda management for my participation. Thank you, sir.
Thank you, ma'am. It was nice presentation. And you have one question in chat box. Can you see? Srisa?
Yes, sir.
Can you see? Right. Read. After increasing RGO to 2%, what happened to specific capacitance? Did you check?
We have tried 1.5% only. We didn't try for 2% of RGO. We didn't check, sir. We will check for further studies.
Okay.
Thank you, sir.
Okay. Thank you.
Next one. Hello.
Sir.
What is a partition function?
Sir.
What do you mean by partition function?
Partition function. I don't know, sir. Partition function.
Okay. Okay. You are measured the physical capacity.
Yes, sir.
Okay. Fine. Okay, ma'am.
Okay, sir.
Okay, thank you. Thank you for the introduction. Next, I would like to call upon R. Radhika, PhD scholar from Gobi Arts and Science College, Gobi Settipalayam. Just I remind you, all the participants, we have a time consumption. I take it only 5 minutes. Thank you. Radhika.
Yes, sir. Shall I start, sir? Shall I start, sir?
No, it's not visible now. Just
The slides are visible.
no, ma'am. It's just taking a couple of minutes. Yes, ma'am. It is visible now. You can start.
Okay. with my work in the topic green synthesis of TiO2 nanoparticles for dyes and solar cell application under the guidance of Dr. D. Venugopal. The surface to volume ratio is reduced to 10 from -9 meters in scale is called nano. 1 nanometer is 1 billionth of a meter.
Ma'am,
And
there is no
aim is-
introduction needed, madam. You can go to
Okay,
the experiment as well as the resultant discussion.
Okay, sir. Synthesis of TiO2 nanoparticle, we taken 100 ml of ethanol dropwise added TTIP at 1100 RPM for 2 hours. The Plectranthus amphonicus leaf extract added dropwise to adjust the pH level, pH to 467. Again stirred for 1 hour and kept in a muffled furnace at 450 degrees Celsius for 2 hours. Here, we don't have used any acid to change the pH. We have used only Plectranthus amphonicus leaf extract to change the pH level. These TiO2 nano powder made into paste by adding glycerol and the FTO substract coated with Dr. plate technique, and these working electrode was dipped with 0.5 mm RP dye. The working electrode is noted as A. The counter electrode used as a graphite. These counter electrode and photo anode binding with binder clips. The electrode solution are added before the taken of IV characteristics. Here, when the sunlight falls, the solar cell TiO2 conducting film get electrons. The one electron excited from HOMO to LUMO of the RP dye. The excited electron goes to conduction band edge of the semiconductor nanoparticles. These electrons are collected by the electrolytes at the counter electrode. The dye lost 1 electron and it takes 1 electron from the electrolyte solution. The movement of electrons from anode to cathode produces current. This is the working principles of Dyson-Stride solar cell. This is the XRD pattern of prepared TiO2 nanoparticles by using Plectranthus amphonicus leaf extract. The figure shows it contains tetrahedral structure and exhibits anodized phase. The average crystalline size was calculated by using Debye-Streller formula. The average crystalline size decreases to 20 nanometer to 10 nanometer. We don't have any changes while increasing the pH value. The changes only occurs in the surface of the TiO2 nanoparticles. This is the figure shows the same images of prepared nanoparticles. It is very uniformly distributed spherical shape without agglomeration. This is the EDAX spectra of TiO2 nanoparticle by using Plectranthus amphonicus. This is the FTO spectrum of prepared TiO2 nanoparticles by using Plectranthus amphonicus leaf extracts. Here, the band gap also decreased up to 2.98 electron volt. This is the absorption spectrum of TiO2 nanoparticle. This is the IV character of prepared nanoparticle. His efficiency for pH2 is 0.8 and reduces to 0.9, 1.1, 1.35 for pH7. The novelty of work is Plectranthus amphonicus leaf extract to change the pH. They have more flavonoids. So when sunlight falls on the TiO2 surface, it adjusts their absorption bandwidth near IR region. So they have more hydroxyl and carbonyl group. It should be an anchoring. It should be an anchoring group in DSSC. The 4 conditions are there to working DSSC. First, near IO region, and it must be have a anchoring group. And LUMO of the dye is more positive than the electrolyte solution, and the HOMO is and the conduction band edge is near to HOMO. The conclusion, the XRD results revealed that the formation of TiO2 nanoparticles anodized phase and the average crystalline size in the range of 21 to 10 nanometer. In SEM analysis, the green synthesis nanoparticle are distributed consistently with a spherical shape with shape morphology without agglomeration. In EDAX spectra of TiO2 prepared under optimized condition and conformed only for Ti and O. In UV has been observed that the direct band gap energy decreased corresponding to the ratios from 3.29 to 3.21 electron volt. In DSSC assembled for prepared TiO2 nanoparticles exhibited efficiency reached 1.3%. Suppose we have to use the Plectranus symphonicus as well used as a photosensitizer in DSSC, definitely the efficiency reached the maximum. And TY2 provides a fast cleanest from producing nanoparticles. This biological reduction of metal would be benefit for the evaluation of clean and non-toxic and environmentally suitable green approach to produce metal nanoparticles. Thank you.
Thank you, ma'am. What is the crystal purity of your from the XRD, madam? What is the purity of the phase estimated from the XRD?
Anodized phase.
That is okay. What is the purity? It is 100% single phase, or you will get some multiple phase?
It is a 100% single phase.
Oh, there is no secondary phases.
No, sir. No, sir.
Okay. Okay, ma'am.
Okay, thank you, sir.
Okay, thank you, ma'am. Thank you, sir. Next, I'd like to call upon HR Pradeep, research scholar from Kongunadu Arts and Science College, Coimbatore.
Hello, sir. Good morning, sir. Am I audible?
Yes, sir.
Yeah, okay. So I'm HR Pradeep, research scholar from Kongunadu Arts and Science College, Coimbatore, under the guidance of Dr. B. Chandrasekhar, sir. My topic is fabrication of high efficiency volume phase holograms in silver alloyed materials for solar concentrator applications. For small introduction for the solar energy, the solar energy's attention came from the huge consuming problem of the fossil and fuel crisis. There are two most significant sources of nuclear energy and solar energy. We can convert the solar energy into the electrical energy and mechanical energy and thermal energy extra. The solar energy is completely free source of energy, and it helps to reduce the greenhouse effect and global climates. Here we are using the solar concentrators.
It's not visible.
Yes, sir.
Your presentation is not visible. Please
Just
present
wait.
your screen.
Yeah, just wait. So it's come. The screen sharing has failed to start, sir. Now it's okay, sir.
No,
It's visible.
still not visible. Organizer.
Sir, we can call the next person, sir. Then he can present after some time.
Okay, sir. Okay, sir.
Okay. Thank you, sir.
Okay, sir. Thank you. Next, I'd like to call upon M. Ramuday, research scholar from Kalasalingam Academy of Research and Education. M. Ramuday. Are you present here? M. Ramuday.
Sir. Hello, sir.
Yes.
Sir, is audible, sir?
Yes, audible. You can start your presentation.
Okay, sir. Thank you, sir. One minute, sir. Full screen. Full screen, right? Good afternoon, everyone. My name is Ramtai. I'm doing research scholar with Department of Physics, Kalasalingam Academy of Research and Education under the guidance of Dr. K. Viswanathan and the co-guidance of Dr. S. James Jain, sir. Now I am going to present one of my research work This is of the content of my work. First of all, introduction of compound. Second one, DFT studies, manuscript details, and conclusion. The introduction of compound is first of all, I chosen the biomolecules, the sum of the biomolecules. These are the biomolecules. First, this is the Gaumarin. I have chosen the Gaumarin derivatives, and this is the formula, order, and appearance. This is some basic introduction about this. These are benefits of the Gaumarin. This is the main focus of herpeticis and laser technique and working cell damaging fluorescent dyes. And this is the structure of the Gaumarin structure. From literature survey, I have chosen the Gaumarin derivatives. Hydroxy-Gaumarin. It is a promising area of the medical side promising area, and it is a main focus of anticoagulant, antioxidant, and anti-HIV. This is a literature survey of the hydroxy-Gaumarin. Then my main part of the work is DFT studies. It is a theoretical studies of the my compound. I have chosen the theoretical part of my molecule optimized by DFT basis, B3LOFP basis. This is the investigate the atomic structure in polymer particular atoms and molecules. My molecule 7-methoxy-Gaumarin was optimized by DFT method with Gaussian 09 software, and the vibrational wave numbers are assigned and is used into Veda software. This is the optimized compound, and this is the structural parameters and CCPTV, the table column. This is abstract my compound. My compound is promising area of the by cytotoxicity docking result. It's a promising area to the human leukemia cell. Cytotoxicity and docking results I have did it after that. And this is the theoretical vibration analysis of my compound. OH, CC, CO, CH, this vibrations are assigned. This is the energy gap bond, homoluma energy gap bond, 4.7 electron volt I have noted. And this is the docking studies. This is the docking studies of my compound. By these three proteins, my ligand was binding with ERF. This is the protein of the structure. And cytotoxicity assay. From 5 various cell lines, I have my compound has good agreement with the HL60. HL60, the sample line was human leukemia cell line. So this is the from this various and 5 cell lines, I have this human leukemia cell line good reported with for the compound. So my conclusions is first of all, theoretically my molecule was optimized, and the MEP studies and the homoluma studies are the reactivity compound very good. And furthermore, the main compound of my compound is cytotoxicity and docking analysis very recognized inhibited through the leukemia cancer cell line. So thank you, sir.
Thank you, ma'am. It was nice presentation. Audience, have any
sir?
questions? No, ma'am, no. Okay, sir, next.
Okay, thank you, ma'am. Thank you. Next, I would like to call up the next participant, Tilaka, research scholar, SRNM College, Satur. Slide number 26.
Sir, am I audible, sir?
Hello?
Am I audible, sir?
Yes, ma'am. Yes, you're audible. You can start.
Okay, sir. Good afternoon, everyone. I'm Tilaga. I'm doing research in Sadakatula College under the guidance of Dr. P. Selvarajan and Ms. M. Abdul Kader, sir. And now I'm going to present my work on effect of citric acid on chrome alum crystals. And this is the plan of the talk today. And let me go to the synthesis part. The sample under present investigation is a potassium chromium sulfate. The title compound was synthesized by dissolving AR grade chromium sulfate and potassium sulfate.
and then you can go to the resultant discussion, madam.
Sir, I'm not audible, sir.
You can mention the method of sample preparation. Only you can mention a method, then you can go to the
Okay.
resultant discussion. Okay.
Okay. The method of preparation of samples is slow evaporation technique. We use that, and in that we added some lemon juice to reduce the pH and solubility, and we also performed the solubility study for different temperatures using gravimetric method. And from this figure, it is observed that the solubility of PCS sample in water linearly increases with the temperature, which exhibits a high solubility gradient and positive temperature coefficient, and which reveals the fact that the slow evaporation technique is appropriate method to grow the single crystals of PCS. This is what we have obtained after a period of 20 days. And coming to result and discussion, the obtained lattice parameters of PCS sample from a single crystal XRD diffraction are given here. The grown crystals crystallizes in cubic crystal system. Coming to the FTIR analysis, the spectrum is shown here, and the peaks also indicated in this table. And the peak at 2358 centimeter inverse corresponds to CH stretching, and 1642 corresponds to OH bending, and 703 is due to H2O rocking, and 613 is due to chromium stretching. And coming to the UV visible analysis, the optical transmission spectrum of grown crystal was recorded by UV visible spectrophotometer, and the crystal have found to have good transmittance in the visible region. And it is noted that UV transparency cutoff occurs at 237 nanometer. And the good transparency and lower cutoff wavelength of this material enables them to be a good candidate for optoelectronic applications. And the band gap value of PCS sample was found to be around 5.63 electron volt. And the high band gap reveals that the PCS sample is a promising material for nonlinear optical applications. And coming to EDAX, the spectrum is shown here, and the elements such as oxygen, sulfate, potassium, and chromium are present in this crystal, grown crystal. This also reveals that the added lemon juice does not make significant change in the elemental composition. And coming to the micro hardness test, this was performed for our sample for various loads from 25 to 100 grams, the steps of 25 gram with constant period of 25 seconds. And the hardness number is calculated for various loads, and the variation of hardness number with applied load is shown in the figure. And by plotting a graph of log P versus log D, work hardening coefficient was calculated, which is shown in this table. And according to Onstrid, since N is greater than 1.6, it's concluded that the PCS crystal is a soft material. So the yield strength and the stiffness constant of the grown samples was also calculated. And it is observed that the values of yield strength increases with the applied load, and hence the grown crystal have relatively high mechanical strength. And high values of stiffness constants indicates that the binding forces are very strong. And let me summarize quickly what we have discussed so far. Good quality single crystals of PCS have been grown by slow evaporation technique, and the solubility study was estimated for water as a solvent for different temperatures, and X-ray diffraction studies confirms the cubic structure of the grown crystal, and the functional groups were confirmed by FTIR analysis, and UV studies reveals that good transparency and low cutoff wavelength of the grown crystal, and also it shows that the grown crystal is an appropriate material for optoelectronic applications. And EDAX spectrum shows the presence of these elements in the PCS sample. And the mechanical analysis reveals that the hardness increases with the increase of load. And from the values of work hardening coefficient, it's concluded that the grown sample belongs to the category of soft materials. And these are some of the references. And we are thankful to the management of Althanar College of Arts and Science, Sarakatullah College, Tirunelveli, and we would like to extend our thanks to Stick Cochin and St. Joseph College, Trichy. Also, I will extend my thanks to Vivekananda College for their support. Thank you. Sir?
Nice presentation, ma'am. You have one question. You have one question in chat box.
Okay, sir. Let me check, sir.
That,
Sir, not able to see that. Can you read, sir?
okay, ma'am.
Yes, sir.
How to calculate band gap if two peaks are there in optical transmittance spectra? Which peak is considerable as both look same transmittance? Can you please explain? So this.
Sir, by plotting top plot, we calculated the band gap, sir.
Okay, ma'am. Another one, Ramamurthy Sengan. Could you post your question in chat box? Ramamurthy Sengan.
Sir?
Ma'am,
Sir, I have read the question. Can I answer?
Yeah.
Yes, sir. We can also use screen synthesis and grow crystal. Actually, we are trying for that only for this particular crystal. We actually we are using onion juice, and we are now going to characterize those crystals. And let me do this as a future work, sir. And we can do this because pH reduces, so that all the properties will change, sir. So we can add green materials as a dopant.
Okay, ma'am. Thank you.
Okay, sir. Thank you.
Okay.
Okay, thank you. And one more participant left last. H or Pradeep. This is the last presentation. Research scholar, Community Arts and Science College. Sir, are you ready now? Pradeep from Pongunada Arts and Science College. If you are ready, you can present a presentation now. Slide number 23.
Make him hold first.
Okay.
Hello, sir. Sir, am I audible?
Yes, Pradeep.
Yes, sir. Please share the screen.
So the same problem is repeating, sir. Screen
Okay, you
is
can
not sharing.
organize us for this regarding this, sir.
What, sir?
You can contact the organizers for this kind of difficulties.
Organizer, is it possible
So now it's visible, sir?
to share his screen? Now it's
Yes,
okay.
yes.
Okay, you can proceed.
Sir, visible, sir?
Yeah, it's visible. Make it full screen and give a short intro
sir.
about your research and come to research and discussion.
Yeah, okay, sir. My topic is fabrication of high efficiency volume phase holograms in silver allied materials for solar concentrated applications. The main advantage is the solar concentrator is to increase the output and efficiency of the solar cells. The solar cells having main drawbacks of low output efficiency. So we need to improve the output efficiency of the solar cells.
Sir, skip the introduction, if possible.
Yeah, okay, sir. There are conventional holographic concentrators and holographic solar concentrators are there. We are using the holographic solar concentrators. There is the two types of holograms are recording: inline hologram and off-axis hologram. The transparent object illuminate with the columnate beam and the record interference pattern. This is the inline hologram. On the off-axis hologram is a separate reference beam and incident on the plate with desired angle and recording the interference pattern. This is the transmission hologram. This one is transmission holograms recording method, and this one is the reflection holograms recording method. There are some applications of the solar shading device and holographic weapon set inside the hologram and the holographic solar concentrators. So in this method, the recording geometry is we are using the helium neon laser 632.8 nanometer, and there is the electronic shutter, and the beam splitter is there. This single beam divided by this beam splitter, this one is reference beam and this one is the object beam. So this is the holographic plate. In this place we can place the silver allied materials. So we can record this is the schematic of experimental setup. This was the front view on the back view. The laser output power is 25 milliwatt, and the beam ratio with the reference beam and the object beam is 1:1. The incidental angle is 22 degree, and the exposure energy is 2 minutes 18 seconds, and the developing time is 1 minute 8 seconds, and the bleaching is 25 seconds. So we can achieve the 76.9% of efficiency of the diffraction beam. This is the recorded holograms, and this one is the hologram placing in the measurement setup. This is the direct beam transmitted, and this one the right side diffracted beam, and this one is the left side diffracted beam. So this is the spectrum of the hologram, and the machine result is for the 632.8 nanometer helium neon laser, we can measure. This is the incident velogram, this is the volume phase hologram, this is the incident beam, this one is the right side diffracted beam, left side diffracted beam. This is the power meter. We can achieve the 76.9 efficiency. This one is the 532 nanometer DPSS laser, and this one is 441 helium cadmium laser. We can the red, blue, and green. The three wavelengths were measured. Finally, we can achieve the 76.9 at 22 degrees, 72.7 at 18 degree, 54.5 at 15 degree. This one is red, green, blue. So red wavelength and the green wavelength efficiency and the blue wavelength efficiency. This is efficiency comparison with three wavelengths on right hand side. These peak 22 degree, 18 degree, and 15 degree. This is left side. This 22 degree at the same 18 degree and the 15 degree. So at the conclusion, we can use the multi-junction solar cells in the volume phase holograms. We can use in this transmission hologram placing on the solar cell. We can track the solar suns, and we can achieve the output efficiency more on the solar cells. Thank you, sir.
Thank you, sir. So the next presentation.
Sir, the oral presentation is already over. We're going to start the next session, sir.
Okay, sir. Thank you, sir. Okay, sir.
Thank you so much for all the oral presentations. We're going to start the next session. No matter how good your intentions are, the world judges your presentations. No matter how good your presentation is, God judges your intentions. We will going to start the poster presentation. Poster presentation is a kind of art. Through presenting your posters, you are going to demonstrate and explaining the concept and the ideas you have. This is very simple and easy method, and it is understandable to the audience easily. So I would like to start the session by, I will call you as per the schedule, one by one. You can present your posters. Okay. Thank you. And I request all the participants due to the time consumption, take it only a minute, couple of minutes. And be ready for all the poster presenters. I'll just name out the list. First, S. Sugarti, then second, Rimi Mondal, third, Raja Manigantan, fourth, Asis Anil, fifth, Agleswari, sixth, M. Magesh, seventh, Singh Charan, then finally, Visruda. There are 8 poster participants are there. Be ready for your poster presentations. I like to call upon the first presenter, S. Sugardi, research scholar, SRM Institute of Science and Technology. Sugardi, ma'am, are you present here? Sugardi, unable to unmute in there.
Thank you, sir. Hello, sir.
Yes.
Yeah, am I audible?
Yes, ma'am, you are audible. You can start with.
Yeah. Okay, sir. Thank you, sir. Can you please share my poster?
Yes, ma'am. Just ma'am.
Yes, sir.
Are you able to share your screen?
No, sir.
Do you have that facilities?
Yeah, yes, sir.
If you can share your screen. Otherwise, we will do it now.
So can you please share it? Actually, I couldn't able to open that file actually. I can share the screen, but that file is not opening.
No problem, ma'am. It is already shared. You can proceed.
Okay, sir. Because I didn't see that. Okay, sir. Thank you, sir. Good afternoon to all. Myself as Sugarti, research scholar under the guidance of Dr. G. Bakiraj, SRM Institute of Science and Technology. I'm also working in the Laboratory of Functional Materials and Energy Devices. Head of the laboratory, Dr. M. Navneethan. So today I'm here to present my ongoing research work. It's a biomolecule assisted 156 metal chalcogenate composited with reduced graphene oxide for contracted applications. So before going into the work, I need to explain the introduction. So first we need to know the introduction, like background of energy. Due to the energy crisis, we need to go for an energy sources. We have 2 energy resources like renewable and non-renewable energy. So solar energy comes under renewable energy. Why we need to go for solar energy means it is an ample source of power in this world, so we need to go for that. So solar cell is used to obtain the solar energy, and it is converted into the electricity. So it has 3 generations, like first, second, third. Like now we are in the 3rd generation solar cell, Dyson's ray solar cell. Why we need to go for an 3rd generation solar cell such as Dyson's ray solar cells means now in Dyson's ray solar cells we have achieved 14% of efficiency, and perovskite solar cells 23% of efficiency, around 23%. Like so due to that, so we need to go for an 3rd generation. Also we have some drawbacks in first and second, like large cost, high cost and toxic elements. So we need to go for a third generation solar cells. In that I'm taking dye-sensitized solar cells. Why I'm going for dye-sensitized solar cells means it is a low cost and easy fabrication solar cells. So mainly it has mainly 4 components such as photoanode composed of semiconductor metal oxide and sensitizers and electrolyte and counter electrode. So in that I'm focusing on counter electrode. Why I'm going for counter electrode means it has mainly the noble metal platinum is used as a counter electrode for all the dye-sensitized solar cells. In that it has some drawbacks such as high cost and it limits the large scale applications, but it has specific qualifications such as high catalytic activity, high surface area. But due to that problem statement like high cost and large scale limit the large scale applications, we need to go for an alternative materials for counter electrode application. So I'm taking this as my research work. So I'm going for an alternative material for platinum. So in that I'm taking AgBas2, silver bismuth disulfide. Why I'm going for silver bismuth disulfide means it is a highly ionic material and it has low Albach energy. It easily fast transient photoconductive response and it has a high electrical conductivity. Also it has an absorption coefficient of about 10 power 5 per centimeter in the visible region. So because of these advantages, I'm going for this material as an alternative counter electrode materials. Objective of my work is to synthesize AgBas2 in an effective way and to alternate platinum with the transition metal AgBas2. So here I'm using solvothermal synthesis as an synthesis process of my AgBas2. So here I'm composited with GO. For GO, for preparation of GO, I'm using modified Hammers method. So separately, I'm preparing GO and adding the GO into AgBas2 synthesis process with different percentages. So after keeping in furnace for 180 degrees Celsius for 24 hours, so I have centrifuged and characterized. So here I'm giving my characterized studies like XRD pattern. From XRD pattern, I have confirmed that AgBas2 has formed and it is well matched with the JCPS core number 892045. Also, there is some binary compounds such as Ag2S, Ba2S3, like silver sulfide and bismuth sulfide. And the graphene XRD pattern of graphene oxide shows the formation of graphene oxide, and there were no graphitic peak appeared at 23 degree, and when I composited with the AgBas2, there were no peaks of reduced graphene oxide in the XRD pattern. It is due to the weakened intensity of RGO, and it confirms the intercalation of AgBas2 with the RGO. And to confirm the presence of graphene oxide, I have done Raman analysis. So in that, it shows the D band, G band at 1300 and 1500 per centimeter. So it confirms the presence of graphene oxide. And when I composited with the AgBas2, there is some intensity difference in material peak and graphene oxide peak. So it is due to the intercalation of material and GO. By calculating the ID by IG ratio, the ID by IG ratio is gradually increased and decreased. For RGO2, I'm getting 1.29 ratio. It confirms that it confirms the interaction between materials and GO. So next, FESM analysis. So from FESM analysis, I have confirmed that the nanoflex morphology has formed for AgBas2, and by adding the composition of graphene oxide, the graphene oxide shows the nanosheets morphology, and the nanoflakes were deposited on nanosheets. So to confirm the morphology studies, and I have done TEM analysis also. In that the flakes were present on that nanosheets, and I got lattice fringes as 0.28 nanometer. When I added also, there is no changes in lattice fringes, but but it confirms the intercalation of AGBS2 with GO. And where I have done optical analysis, so that it shows the absorption of absorption at UV region and visible region also, and it beyond goes to that NIR region also. By calculating the torque plot, I have obtained the band gap of 0.96 electron volt, and it is gradually decreased due to the composition of graphene oxide. So next. So far I have done this characterization. Next I have to fabricate the device, and I have to done the cyclic voltammetric analysis, IV measurement. So conclusion, so the XRD pattern of AGBS2 is well matched with the JCT score number 892045, and the maximum intensity of reflection plane 200 indicates the growth direction of AGBS2, and the FESM micrograph shows the AGBS2 nanoflakes morphology, and it is deposited on nanosheets of graphene. The Raman analysis confirms the presence of D and G band defect states of graphene, and in future we have to analyze the cyclic voltammetric and IV measurements. Acknowledgement, I would like to thank SRM IST for their funding support, and Nanotechnology Research Center and SRM SA for their characterization provided. Thank you.
Thank you, ma'am. Any questions? Okay. So we move to the next participant. The question in the chat box. Ma'am, yeah, there is a question in the chat box. You can answer for them.
Yeah, Shivashalini, right? Yeah, actually, we can use this material for supercapacitor application also. Even I have done that studies also using nickel foam and KOHL's electrolyte. But my work is based on solar cell applications. So I need to use the FTO substrate. So I haven't shown that result here. So we can use for supercapacitor application also.
Okay. Sir, any questions from chat persons?
No, sir, we can move next.
Oh, okay, sir. Okay, sir. Next, I would like to call upon the next participant, Remy Mondal.
Yes, sir. Yes, sir. Sir, am I audible?
Yes, you are audible.
Yeah, sir. Please share my slide now. Please share my poster now, sir.
Okay. Ma'am, do you have facility to? Do you have that facilities? You can share your screen.
Okay, sir. I'm trying it, sir. If it doesn't happen, then please share it, sir.
Okay.
Okay, sir. No, sir, it's not happening.
Okay, ma'am. It is presented now.
Okay. Thank you, sir. Good morning, everybody. I myself Remy Mandal. I am from GRD IMT Dehradun. So my topic is the herbal nanomedicines. So there it goes. Since the ancient times, herbal medicines have been widely used worldwide for their better therapeutic values and fewer adverse effects as compared to the modern medicines. Due to the lack of the scientific justification and processing difficulties, the herbal medicines were not considered for the development of the novel formulation for a long period of time. But now, the modern phytopharmaceutical research can solve the scientific needs of the herbal medicines in the developing novel drug delivery systems like microsphere, nanoparticles, in the developing the matrix system, liposomes, solid lipid nanoparticles, etc. Like in most of the conventional dosage forms, only a limited amount of the administered dose reaches the targeted site, while the majority of the drugs get distributed throughout the body, depending on the physicochemical and the biochemical properties, resulting in the low therapeutic effect. The main advantage of the novel drug delivery system includes the targeted drug delivery, which reduces the dosage frequencies, increases the solubility and absorption, whereas it decreases the elimination. Among all the NDDs, nanoparticles is considered to be an important drug delivery system. So what are these nanoparticles? These nanoparticles are sub-nanosized colloidal structural composed of the synthetic or the natural polymers varying in size of about 1 to 1000 nanometer. And the drug is dissolved and encapsulated or attached to this nanoparticle matrix. And depending upon the method of the preparation, these nanoparticles can be nanospheres or the nanocapsules. And these nanocapsules are the systems in which the drug is confined to a cavity surrounded by a unique polymer membrane, while the nanospheres are the matrix systems in which the drug is physically or uniformly dispersed. And this nano carriers, they are physically and uniform, they are like made with the safe materials or including like synthetic biodegradable polymers, lipids and polysaccharides. Why we need these nanoparticles in the herbal remedies? These nanoparticles can be used to target the herbal medicine to individual organ, which improves the selectivity, drug delivery, effectiveness, and the safety. These nanoparticles can be utilized to increase the herbal drug solubility and to help the localize the drug in a specific site, thus resulting in a better efficacy. Then the nanoparticles can deliver the high concentration of the drugs to disease sites because of their unique size and high loading capacities, and delivering the drug in small particle size enhances the entire surface area of the drug, therefore allocating the quicker dissolution in the blood. And this shows the enhanced permeation and retention effects, enhanced permeation through the barriers because of the small size, retention due to the poor lymphatic drainage. And other than this, they also exhibit the passive targeting to the disease site of the action without the addition of any particular ligand moiety. And other than this, they decreases the side effects also. So we have many types of herbal nanoparticle formulations like Artemisia annua, that is a single-stemmed annual herb of a family Asteraceae. This artemisinin is the active principle of this Artemisia annual plant, and it has the potent anti-malarial action. Due to its poor pharmacokinetic properties and the short half-life, its clinical application is restricted. So because of that, the nanocoated artemisinin have been developed to overcome the problems associated with the artemisinin. This nanocapsule dispersed well in the aqueous solution, and hydrophilicity of artemisinin crystals were also improved after the encapsulation. Next is the berberin. Berberin is a naturally occurring isoquinoline alkaloid present in the roots, rhizome, and the stem bark of the number of the medicinal plants, such as like Berberis vulgaris. Family is Berbedaceae. Other than this, it is present in Ctenospora cordifolia. This berberin has a tremendous potential to cure many physiological disorders. Moreover, the anti-tumor properties of this berberin have been achieved on human malignant brain tumor, esophageal cancer, human leukemic and colon cancer cell lines. So this berberin-loaded nanoparticles are successfully prepared using the single emulsion, multiple emulsion, and ionic gelation methods for sustained drug release. Next is Centella asiatica. It is a small herbaceous creeping plant. The biological name is Centella asiatica. The family is Apiaceae. It has a wide range of pharmacological applications such as anxiolytic, anti-anxiety, or antioxidant. It is also used for the treatment of leprosy, wounds, cancer, fever, allergy, and the syphilis. This Centella asiatica extract possesses a high potential biological activity. Its clinical usage is limited to some extent due to its physical instability. This powder extract shows a high hygroscopicity, so therefore the development of the nanoparticles in which the extract is entrapped inside could protect it from the external moisture. Then other than this, chitosan alginate nanoparticles of this Centella asiatica extract, it has been prepared by the ionic gelation method. This nanocapsulation of this plant extract can provide the physical stability compared to its extract alone. Next is our curcumin. We get it from that turmeric. We know it, how it is important to our daily lives. We use that in our food. That curcumin is a hydrophobic polyphenol. It is a potent phytomolecule obtained from the turmeric. The curcuma longa, a family is Gingiberaceae, has a wide range of biological activities, such as we know it can be used in the anti-cancer, anti-inflammatory, antioxidant, antiviral, antibacterial, antifungal. But its clinical application was limited due to its short half-life and poor water solubility, rapid metabolism, rapid elimination, and ultimately results in the poor bioavailability upon the oral administration. So that's why the nanoparticle-based drug delivery approaches have potential for rendering the hydrophobic properties of the curcumin. The nanoparticles of the curcumin have been prepared by the process of wet milling techniques. And other than this, unlike curcumin, nanocurcumin is freely dispersible in the water. Next is the danshin. Danshin, it is a dried roots of the Salvia miltorrhiza. The family is Lamiaceae, are widely used as a medicine for promoting the circulation, improving the blood stasis. This danshin is extensively used for the treatment of coronary heart diseases, cerebrovascular diseases, and hyperlipidemia. The slow pharmacological action is the major drawback of this herbal drug, and so that's why the nanocoated Salvia miltorrhiza exhibits a stronger antioxidant property, and the release was much faster than that of the traditionally powdered sample. The phospholipids complex loaded nanoparticles also enhance the oral bioavailability. Next is our dodder. Dodder, it is obtained from the parasitic plant, that is the Cuscuta chinensis. Family is Convolvulaceae. The major chemical constituents are like flavonoids and lignans. Its pharmacological activities include like anti-cancer, anti-aging, and immunostimulatory effects. Its absorption upon the oral administration could be limited due to its poor aqueous solubility. The nanoparticles of this Cuscuta chinensis have been developed by the nanoprecipitation method. And compared to ethanolic seed extract, the nano-coated Cuscuta chinensis exhibits higher hepatoprotective and antioxidant activities at lower concentration. Next is genestin. Genestin is a isoflavone, and it is a primary active component of the soybean or other leguminous plant. It is a phytoestrogen and antioxidant. It also has the ability to decrease the risk of osteoporosis, cardiovascular diseases, or the breast and uterine cancer. Its clinical application is decreased due to its low aqueous solubility and poor bioavailability. So that's why the formation of this genestin nanoparticles improve its solubility and the bioavailability by the nanoprecipitation method. And it was found that genestin loaded nanoparticles possess higher like about 241.8% relative bioavailability compared to the genestin alone. Next is Moorva. Moorva, it is a controversial drug obtained from the many medicinal plants such as Marsdenia tenacissima, Roxburgh, like Clematis triloba. The family is Ranunculaceae. Other than this, in Bahonia tomentosa. So it has the potential to treat diseases like anemia, fever, diabetes, stomach disorders, typhoid, urinary infection, and cough. Due to its low aqueous solubility and poor bioavailability, its use is limited in clinical application. Thus, to increase its solubility and bioavailability, it is formulated as nanoparticles. Next is the paclitaxel. Paclitaxel is a major anti-cancer drug isolated from the bark of Taxus brevifolia, but its high lattice energy results in very limited aqueous solubility, limited to its efficacy. Thus, incorporation of the paclitaxel into the nanoparticles enhance its anti-tumoral activity. Other than this, the paclitaxel loaded nanoparticles were prepared by nanoprecipitation method and by sequential simplex optimization method. And this paclitaxel nanoparticles enhance the drug stability, support the sustained drug releases, and also improve the bioavailability. Next is quercetin. Quercetin is it is a flavonoid extracted from air-dried plant of the Spora japyonica. That is a family is Fabaceae, mainly from the bark and the leaf. This antioxidant activity of the quercetin is higher than well known of the antioxidant like ascorbyl or trolox. But apart from that, it also has the antioxidant activity. It shows the anti-cancer and then the antiviral activity. In spite of this wide spectrum of the pharmacological properties, its use in the pharmaceutical field is limited due to its low aqueous solubility and instability in the physiological medium results in the poor bioavailability. The nano encapsulation of the quercetin into a poly-D or L-lactide, the nanoparticles significantly improves the therapeutic efficacy and bioavailability. The quercetin loaded lactide or poly, the PLM, the nanoparticles have been prepared by the solvent evaporation method and by using the bovine serum albumin. So at present, these herbal medicines have been getting more attention because of their potential to treat almost all diseases. However, several problems like poor solubility, poor bioavailability, low oral absorption, instability, and unpredictable toxicity associated with this herbal medicines limited their use. In order to overcome such problems, we have this nanotechnology. It has established the attractive therapies to the pharmaceutical that will encounter the problem associated with this herbal medicine. It is anticipated that effectual and valuable relevance of the natural products and the herbal remedies being applied with the nanocarrier will enhance the significance of the existing drug delivery system. Thank you so much. Any questions, sir?
Thank you, ma'am.
Yeah. Thank you, sir. Any questions, sir?
From the audience side?
Yeah, sir.
Chairpersons? Any questions from audience? Okay, no questions. Thank you, ma'am.
Thank you, sir.
Thank you. Next, I call upon R. Raja Manigandan from Bardiyar University, Coimbatore.
Sir, can you hear me?
Yes, sir. Yes, sir. Yes, sir.
Sir, can you see my poster?
No, sir. No, sir.
Sir, wait
So
a
just a
minute.
minute. Okay, sir. Okay, sir. Your screen is visible now. You start your presentations.
Okay, sir. Yeah, very good afternoon to all. I'm happy to present my research work entitled Highly Fluorescent Protein Stabilized Gold Nanocluster as a fluorescent platform for selective cyanide sensing in real water samples. Yeah, it is well known. Cyanide is highly toxic in nature. In view of this above objective, we have detect cyanide in real water sample is highly necessary. In view of this above objective, we have prepared first protein stabilized gold nanoparticle as a nanoprobe. An appropriate amount of protein and gold appropriate amount of protein and cold chloride is mixed. Then in alkaline condition, then this reaction mixture was stirred in 37 degrees centigrade. The colorless solution turned into yellow in color indicates the formation of cold nanoclusters. The as prepared cold nanoclusters were characterized by using excitation, emission, UV visible, H atom, TLS, and zeta potential measurements. From these measurements, the as prepared protein stabilized gold nanocluster is successfully formed. After successful characterization of cold nanocluster formation, this was the nanocluster was further applied in the field of chemosensing applications. Cold nanoclusters with the increasing concentration of cyanide ions, emission properties and absorption properties is decreased, whereas color also changes from yellow to colorless. Here fluorescent color also changes to red to blue in color, which blue indicates the formation of protein is released in the form of protein stabilized nanocluster into cold nanocluster surface. The observed fluorescent spectral and color response is due to the cyanide aging process in the surface of gold nanocluster. The observed spectral data is plotted against the concentration of cyanide ions. From this plot, LOD is calculated. The calculated LOD is 68 nanomolar. The present emission spectral profile was examined by using STEMomer and fluorescent lifetime measurement. From these measurements, this fluorescent quenching is static in nature. The cyanide etching process was further verified by using HRT measurements. Cyanide only stimulated the emission spectral profile and color of the overall stabilized gold nanocluster. It clearly indicates that this method is highly selective for cyanide ions. Conclusion: in summary, a simple and cost-effective detection method was proposed in here. Furthermore, the selectivity assay reveals this fluorescent sensor was highly selective for cyanide ions. Then the present method further extended to real water samples. Thank you for your kind attention.
Thank you, Rajamanikandan sir. So, any questions? Okay. Dear audience and participants, if you have any questions, kindly enter your questions in the chat box. Thank you.
Set any questions?
Okay. Thank you, Rajamanikandan sir. Okay, next one.
Okay, sir. Thank you.
Next, I call upon Ashish Anil from Central University of Tamil Nadu.
Hello, sir. Can you hear me?
Yes, sir. Your voice is clear.
Okay. Sir, can you put up my poster?
Just a minute, sir. Just a minute. I will.
So, good afternoon, everybody. This is a presentation of my MPhil work, which I'm doing in Central University of Tamil Nadu under the guidance of Dr. R. Arun. It's based on the electromagnetically induced transparency in a cavity with optomechanical system and which contains an atomic medium. We start off by finding the electric and the magnetic fields of an electromagnetic wave which is confined in a cavity. We assume that the electromagnetic wave has a wavelength lambda and it is polarized in the x direction and has a direction of propagation along the z axis, and from there we have obtained the corresponding electric and magnetic fields using the wave equation and using the method of separation of variables. And then after obtaining the corresponding electric and magnetic fields, the next procedure is to quantize these electric and magnetic fields. It basically involves expressing these electric and magnetic fields in terms of creation and annihilation operators, A and A dagger, and thus it will change these classical fields into quantum fields or other operators. And for that, we start by defining two variables, P of t, Q of t and P of t. Each are expressed in terms of the electric field and magnetic field respectively. And it is these variables are defined so that they satisfy the classical equations of a classical harmonic oscillator. And then we consider the
Ani sir.
Yes.
So sorry for the interruption. Sir, you're not audible, sir.
I'm not audible. Hello.
Just speak loudly.
Okay. Shall I start over? Sir, can you hear me?
Yes, sir. We can hear you. Just raise your voice. That's all.
Okay, sir. Should I start over?
Yes, sir. Yes,
Okay.
we can start over.
Okay. So first we start off with finding the electric and magnetic fields of an electromagnetic wave which is trapped inside a perfect cavity. And for that, we have assumed that this electromagnetic radiation has a wavelength of lambda, and it is polarized along the x-axis, and it has a direction of propagation along the z-axis. And from there, using the wave equation and then using the method of separation of variables, we have found out the electric and magnetic fields. And then the next process is quantizing these electric and magnetic fields of the wave that is trapped inside the cavity. For that, we had to express the electric and magnetic fields in terms of creation and annihilation operators. For that, we start out by defining two variables which are P and Q, P of t and Q of t. These P and Q of t are defined in terms of electric and magnetic fields respectively. They are defined in such a way that they satisfy the equations of a classical harmonic oscillator. And then we consider the total energy of a mode. A mode refers to a particular frequency that is in the particle frequency is the radiation that is of the electromagnetic wave that is in this cavity. And when we consider the total energy of this one mode, and then we express it in terms of P and Q, then we notice that these satisfy Hamilton's canonical equations of a classical oscillator. And then we represent P and Q in terms of A and A dagger, which are the creation and annihilation operators. And from there we obtain the form of electromagnetic field E and B in terms of the creation and annihilation operators, and thus we have quantized the field. Then what we do next is we extend the quantum treatment of a cavity to a leaky cavity. A leaky cavity is one which has a radiation leaking out of it. So for that, what we consider is we consider a perfect cavity from z is equal to minus capital L to z is equal to small l, and then we introduce a partially reflecting mirror that is z is equal to 0 in such a way that we have a or a leaky cavity from z is equal to 0 to z is equal to small l, and from z is equal to minus l to z is equal to 0, we call that a Bardy universe. And from there, we consider the form of the electromagnetic field within that, and we obtain that it can only have values, it can only have certain values, and the coefficients of these certain values changes rapidly because we notice that in a perfect cavity we have well-defined modes or well-defined frequencies, in which only the radiation of the electromagnetic wave can survive inside. When it comes to the case of a leaky cavity, we see that the radiation leaks out, and then there is a spread in the frequency of this electromagnetic wave, which is confined within the leaky cavity. And from there, we have obtained the values of the coefficients of these electric field. We have taken it the value of the coefficient zeta k as plus or minus 1 since there is a spread out of this frequency. The sign of both the mk and zeta k changes rapidly. So to keep mk always positive, we have taken zeta k is equal to plus or minus 1 and then find out the value of mk. From there, we have found out the corresponding fields that come in and come out of the leaky cavity, and the cavity and the field within the leaky cavity itself. And if we define an intracavity creation or annihilation operation, for this purpose we have created the annihilation operator. We see that and when we take its time evolution, we see that there is a noise factor called the Langevin noise factor that is developing inside. For further purposes of our experiment, we assume that the mean value of this noise, we take the mean behavior of the system, and we assume that the noise factor which arises due to the interaction with the universe is 0 because its mean value is assumed to be 0. And then we are moving on to the purpose of our project, that is electromagnetically induced transparency in a cavity. For that, at first we don't consider a cavity doesn't have any medium in it. It doesn't have any atomic medium, and we represents its Hamiltonian, and while representing Hamiltonian, we see terms which corresponds to the cavity, and the setup for this thing involves a cavity which is bound by a fixed semi-transparent mirror on a partially reflecting mirror on one side, and a fully reflecting mirror which acts like a harmonic oscillator on the other side. And electromagnetically induced transparency is obtained by the radiation pressure interaction between a control laser and a probe laser, which is much weaker than the control laser that we use. And when we represent the Hamiltonian of the system, we see that the Hamiltonian consists of energy terms of the oscillating mirror, the radiation pressure interaction between the laser and the mirror, and energy of the cavity itself. And then for further ease of doing the problems, we convert it into a rotating frame with rotators at the frequency omega c, which is the frequency of the control field. And then we apply the Heisenberg's equations, and we obtain the values of the variables that are here, which are the q dot, p dot, a dot, and a dagger dot. And then correspondingly, now we have to consider the quantum fluctuations. Since we are dealing with quantum fields, we have to consider the quantum fluctuations. As a result, we define each operator in as a sum of a steady state and a small variation about this mean state. Then we substitute this further into the Heisenberg's equation that we have used, and then we obtain the value for the electric field which is transmitted. It is a large quantity, and it has both a real part and an imaginary part. The real part is transmitted field gives the absorptive behavior of the system, and the other one gives the transmittive behavior of the system. We are mainly concerned with the real part and the absorptive system. And further, if we proceed by the same procedure in when adding an atomic medium into the cavity too. It just the only difference is the presence of a couple of extra terms, which results in the energy of the atomic system, the two-level atomic system, which we introduce into that, and interaction between the atomic, the cavity field and the atomic system. And proceeding same as before, we know that the only effect of introducing an atomic medium is that it increases the decay rate within the cavity, and thus we are able to obtain a much larger view of transparency. To understand this, we have plotted we have taken the real part of the transmitted field in different cases and plotted graphs in according to the frequency of the.
Sir, sorry for the disturbance. I think due to the time consumption, please make it conclusion, because
yes, sir.
Four more participants are there.
I'm concluding, sir. Last 2 minutes, sir. Just telling the graph. If you look at the graphs, the first graph is when there is no control field, and we can see that the absorbed via the whole probe field, which the probe laser, which we have applied, it's absorbed. And then we have introduced the control field with no atomic medium, and then we see a narrow, where there was an absorption, we see a narrow transparency gap. And when we have introduced an atomic medium, we have seen that the width of that transparency window has increased as we increase the number of atoms in the region. And thus we can conclude that earlier, when there was an when the medium was opaque, or when the cavity was opaque to the probe laser, by introducing this effect of quantum interference, that is electromagnetically induced transparency, we have managed to induce transparency within the medium, and it increases with the increase of atomic medium. As we increase the number of atomic medium, it also increases. Thank you. Any questions? Any questions?
No, sir, no questions. You can proceed next.
Okay, sir.
Thank you, sir. Next, I will call upon Akhileshwari, research scholar, Mysore, University of Mysore.
Dear participants, please start from result and discussion and come to your conclusion. Within 5 minutes, please conclude your topic.
Thank you, Balaji sir, for this information. Akhileshwari ma'am. Akhileshwari, University of Mysore, is there? Okay, next one. Mahesh from RMD Engineering College, Chennai. Yes, Mahesh, student from RMD Engineering College, Chennai. Okay, next slot I will call Singhu Charan Chowdhury from RMD Engineering College.
Sir, I'm audible, sir.
Yes, sir. Now
Sir.
your voice is audible.
Okay, thank you,
Okay,
sir.
carry. Okay.
Yes. Happy noon to everyone who are all present here. I am Mahesh from Electronics and Communication Department from RMD Engineering College, Chennai. I really thanking for the conference. Organizers can selected our poster presentation. We made a poster presentation on the topic artificial muscle using electroactive materials. The poster will be made by our team. The teammates, the authors of this poster presentation, myself, Saran, and Rahul and Vijay Hariharan, as the 4 members can create a poster. About the poster presentation, first we can see the abstract. By studying the properties of an polymers, or now some polymers are respond to the electric field. The polymers are known as the electroactive polymers. The electron of the polymers contract and expand according to the change of electric field by implementing this property in real life, you can create an artificial muscle which is similar to the natural muscle, which has their own advantages. In the context, we have to discuss the artificial muscle using electroactive polymers. We also discussed so many of the drift on artificial muscle, the challenges faced by the scientists in the modern world. Next, we have to see about the introduction from this poster. What are electroactive materials? Electroactive polymers are polymers that respond to electrical simulation with a change in the property or characteristic. Changes can involve a physical deformation, optical or magnetic property variation, and others. Emerged in 1880, while Wilhelm Röntgen was experimenting on natural rubber. And the MP Sacred followed by the Röntgenian experiment by flooding on a theory in response to an applied electric field in 1899. The first piezoelectric polymers were called as electric was discovered in 1995. These are the points of the introduction for the electroactive materials. Then we have to proceed to see what is artificial muscle. Artificial muscle are synthetic materials that behave like a biological muscles. Active materials have also shown that behave microscopically similar to someone of the process taking place in a biological muscle fibers. Then artificial muscles are made up of materials which dramatically smell and shrink under chemical and or an electrical stimuli. Eventually, artificial muscles can be packed into virtual or shape of the size or muscle of the human. Applications could be able to relay. Artificial muscles are also fast and strong. It is a very important steps in developing soft robots that can be both satisfyingly interact with the peoples and complete important tasks. Let we have to see about the basic principles. Bundles of fibers. Just a minute, sir. Sir, you have to scroll up, sir. Sir. The basic.
Yes, sir.
Yes, just scroll up, sir. Yeah, thank you, sir. Let us see the basic principle. Bundles of the fibers made from polymers gels would shrink when implemented in acidic solution, then swell significantly with addition of the base to the impression solution. Immersed in acid solution, negative ions of the polymers will attract to positive ions from the acid that permitted to gel with the resulted in contraction. Some of the immersed alkaline solutions, the gel negative ions was repulsed by negative ions from the solution, causing by the polymers to expand. The chemical effect was similar to action of the natural muscle tissue. And what are the challenges faced by the scientists? Let's have to see. The robotics from electroactive polymers have been consuming too much of energy, making robots that have to ability to mimic the human appearance and operations have been the biggest challenge. Inability of robots to mimic nature, hence affecting the performance of the robots. Remotely operated simulators and robots that have included to virtual reality, a virtual environment have been reported to malculation. Let's have to see, it's a new technology as there is a lot of research and development in it. Next, it is an image for the artificial muscle can lift a 1 kg weight when 3 kg weights of an electricity is applied. And it is the electroactive polymers deformations of a result of applied electrical potential. Now we have to see the brownish colors are the sodium and the dark blue as in water and the purple color as mentioned as in platinum. Now let's have see the current trend for our poster presentation. In the last 15 years, a series of electroactive polymers materials has emerged that produce a significant shape or size in change in response to electrical stimulation. These materials have the closest to function stimulatory to biological muscles, enabling the engineering of naval capabilities that we are up until recently impossible to achieve. Efforts of unable to address the many changes that are hampering to practical application of these materials, and recent progress has already led to dynamic capability improvements. Various novel mechanisms and devices are recommended, including robotic fish and gathering steering elements, robotic arms, manufacture grippers, loudspeakers, active diaphragms, diagram displays are dust whippers. For developers of a future medical devices, that these materials are offering numerous advantages for this flexibility, fracture touches, and controllability, as well as low mass and low power requirements. This is the current trend for that. Next, we have to see the flow chart of that electroactive polymers. The electroactive polymers can divided electrical response and change in the polymer property. And it have to divided into several types: the cell simulation, electric stimulus, and electromechanical response for artificial muscle, antimicrobial behavior, and ionic conduction, electrical conduction, and drug delivery. Then finally, conclusion. The final conclusion: electroactive polymers have evolved the great potential, enabling the development of various devices. As an artificial muscle, electroactive polymers accurating are offering capabilities that are currently considered science fiction. Developing such actors is a recurring development of all front of the field infrastructure. Enhancement of the performance of electroactive polymers will require advancement in the relevant computations. Chemistry models, material processing techniques, making robots are actually the electroactive polymers such as an artificial muscles that are controlled by artificial intelligence would create a new science and technology relatives. While these capabilities are expected to signify change future robots, significant research and development efforts is needed to develop robots of electroactive positive electroactive polymers based actuators. These are the references for using to implement the theory and fix for the poster. Thank you for giving this opportunity. Thank you for all. Especially
Thank you,
thank you
sir.
for Vivekananda College of Arts and Science for Women. Thank you for giving this opportunity. Thank you for all, sir.
Thank you, sir. Thank you for your presentation. Any other queries from audience?
Yes, sir.
Yeah. Okay.
No questions is there, sir.
Okay, sir. We will move next.
Thank you,
Please
sir.
participant. Okay.
Thank you for giving this opportunity, sir.
Next one I call upon Singhu Charan Chaudhary from RMD Engineering College.
Participants, please directly explain from your conclusion. What are the important points that you observed from your research topic? That's enough. Coming from your conclusion.
So please kindly unmute him, sir.
Sir,
Singhu Charan Chaudhary.
am I audible, sir?
Yes, sir. You are Singhu Charan Chaudhary. Your voice is audible. Now you are present your post.
Sir, is my screen visible, sir? So is my screen visible, sir?
Yes, your screen is now.
Yes.
Yes, sir.
Yes, sir.
You start
Good
your,
afternoon, everyone.
your conclusion.
Yes, sir. Good afternoon, everyone. Myself, Singhu Charan from R&D Engineering College. Today, I am here to give a review on solar cell in poster presentation. Now, let's go to the final conclusion. And we'll see brief about the generations of the solar cell. Let's hear the first generation solar cell. The first generation solar cell are produced on silicon wafers. It is the oldest and most popular technology due to high power efficiencies. Bell Laboratories developed the first silicon solar cell in the year 1954 with an efficiency of 6%. The silicon wafer based technology is further characterized into two subgroups named as single monocrystalline silicon solar cell or poly multicrystalline solar cell. Let's see about the silicon monocrystalline silicon solar cell. Monocrystalline solar cell, as the name indicates, is manufactured from single crystals of silicon by a process called Skolke process. The efficiency of monocrystalline single crystalline silicon solar cells lies between 17 to 18%. Now let's see the poly multicrystalline silicon solar cell. Polycrystalline solar cells are generally composed of number of different crystals coupled to one another in a single cell. Polycrystalline silicon solar cells are currently the most popular solar cells. They are believed to occupy most out of 48% of the solar cell production worldwide during 2008. Now let's go into the second generation solar cell. Thin film solar cells are generally known as the second generation solar cells. Silicon wafer cells have light absorbing layers up to 350 μm thickness, while thin film solar cells, which is known as second generation solar cells, have very thin light absorbing layers, generally of order 1 μm thickness. These second generation solar cells are also classified into three types: amorphous silicon thin film solar cell, copper, indium, gallium diselenide solar cells. Now let's see about the amorphous silicon thin film solar cell. Amorphous silicon modules are the primitive solar cells that are first to be manufactured industrially. Amorphous silicon solar cells can be manufactured at low processing temperature, thereby permitting the use of various low polymer and other flexible substrates. These substrates require a small amount of energy for processing. Therefore, amorphous silicon solar cell is comparatively cheaper and widely available. Now let's see about the cadmium telluride thin film solar cell. Among the thin film solar cells, cadmium telluride CDTE solar cell is one of the leading candidates for the development of cheaper, economically viable photovoltaic devices. And it is also the first photovoltaic technology at low cost. CDTE has a band gap of 1.5 electron volts as well as high optical absorption coefficient and chemical stability. Now let's see about the third type of the second generation solar cell, that is copper, indium, gallium diselenide solar cell, generally called as CAGS. CAGS is a quaternary compound semiconductor comprising of the four elements, namely copper, indium, gallium, and selenium. Compared to the CDTE, thin film solar cell, CAGS, hold a higher efficiency that ranges from 10% to 12% due to their significantly high efficiency and economy. CAGS-based solar cell technology forms one of the most likely thin film technologies. The processing of CAGS are done by the following techniques, that is, sputtering, evaporation, electrochemical coating technique, printing, and electron beam decomposition. Now let's see the third generation solar cells. Third generation solar cells are the new promising technologies, but not commercially investigated in detail. Most of the developed third generation cells are nano crystal based solar cell, polymer based solar cell, perovskite solar cell, concentrated solar cell. Now let's see about the nano crystal based solar cells. Nano crystal based solar cells are generally known as the quantum coils, which refer as QD solar cells. These solar cells are composed of a semiconductor, generally from transition metal groups, which are in the size of nano crystal range, made of semiconducting materials. Materials like porous silicon or porous TiO2, which are frequently used in QD. Now let's see about the polymer solar cells, which is generally called as PSC. Polymer solar cells are generally flexible solar cells due to the polymer substrate. A PSC is composed of serially connected thin functional layers coated on a polymer foil or ribbon. It works usually as a combination of donor and an acceptor. If the PSC and other organic solar cells operate on the same principle, is known as photovoltaic effect. Now let's see about the concentrated solar cells. Concentrated photovoltaic, which is commonly known as CPV, has been established since the 1970s. It is a newest technology in the solar cell research and development. The main principle of concentrated cells is to collect a large amount of solar energy onto a tiny region over the PV solar cell. The principle of this technology is based on optics. By using a large mirrors on lens arrangement to focus sunlight rays onto a small region on the solar cell, the converging of the light rays of the sunlight radiations thus produces a large amount of heat energy. This heat energy is further driven by a heat engine controlled by a power generator with integrated. Now let's see the advances in the energy storage. Since the sunlight is not always available, all this business of PV solar cells may not work at night, and a lot of electricity will go unused. Therefore, energy storage is an important factor in solar cell market. Several energy storage devices are available in the market, but those are highly expensive and short lifespan. Recently, in 2014, Harvard University researchers developed a new type. First solar cell energy storage was introduced by WU and his co-workers at Ohio State University. Now let's come to the conclusion. Solar power generation has been developed as one of the most demanding renewable sources of electricity. It has several advantages compared to the other forms of energy like fossil fuels and petroleum deposits. It is an alternative which is promising and constant to meet the high energy demand. Through the methods of utilizing solar energy are simple, yet need an efficient and durable solar material. Technology based on nanocrystal QD of semiconductors based on solar cell can theoretically convert more than 60% of the whole solar spectrum into electrical power. The polymer-based solar cells are also a viable option. However, their degradation over time is a serious concern. And thank you for giving this opportunity. I convey my thanks to Priya ma'am and R&D Engineering College for giving this opportunity. Thank you.
Okay. Thank you, sir. Thank you, Ganesh.
Yes, sir. Thank you.
Any questions from chairpersons or any others?
No, sir. We will move.
Okay. This is the last presentation. I will call upon D. Visuddra, student of R&D Engineering College, Tiruvallur. Visuddra, D. Visuddra, R&D Engineering College, Tiruvallur.
Sir, am I audible?
Yes, ma'am, you are audible.
Okay, sir. Can I present my screen or?
Yes, if you want, you can present, ma'am. Otherwise, we will present your screen. If you can do it.
One second, sir.
Okay, ma'am.
Sir, my screen is visible?
Yes, ma'am, visible. Okay, you can continue, ma'am.
Nanotechnology is an idea that most people simply didn't believe, said by Ralph Merkley. Greetings to all. I am Vishruda Adi, EC student first year from RMD Engineering College, and my co-authors are Fidesh Nadi, Shweta S, Saniboina Haindavi, Tamanini Swarna Vishni, and Dr. R. Priya, our physics faculty from RMD Engineering College, Kavarapete, Chennai. Here we have done a poster presentation on the topic Natural Nanomaterials, a Nature's Gift. This presentation is provided a detailed overview of few natural nanoparticles, its properties and its applications. Naturally occurring nanoparticles show their own physical, chemical and biological activities and promise for their applications in the field, in many fields like medicine, nutrition, cosmetics, agriculture, etc. So during the last couple of decades, the rapidly advancing field of nanotechnology has provided a wide palette of nanomaterials which are considered as synthetic. But despite of this technological sophistication, the materials are always, these nanomaterials are always considered as synthetic in nature. But even though natural nanomaterials also exist, indeed, nature itself is a very good, excellent nanotechnologist. So natural nanomaterials have always been abundantly present in our Earth system for nearly 4.54 billion years ago in the Earth system. So nanotechnology has the ability to work at the atomic, molecular and the supramolecular levels at the range of 1 to 100 nanometers. So it also has a wide applications in various fields, and nanoparticles are atomic or molecular aggregates with at least one dimension from 1 to 100 nanometers that can drastically modify the physico-chemical properties and biological behavior comparing to the bulk materials that we are using it. So nanomedicine and nanoparameters is getting very high popular because of its high tunable properties of the nanoparticles are very useful in targeting drug delivery, cancer treatment of hypermethermia, antibiotics and so on. So here we have done a lots of very few natural nanoparticles, and like that a few examples of natural nanoparticles are gexosfeed, which are used as the adhesives as a practical implication, and shark skin, it is used to reduce the drag suits for the athletes. It's in the suits of the athletes, and wood ligaments and bones are the natural nanomaterial which are used for the structural element, and spider silk, it is used as a high tensile strength fiber and it's very helpful in the textile industries. So here we have discussing, I'm going to discussing about 4 natural nanomaterials in details. First is about the lotus leaf. So this lotus leaf effect is about the lotus leaf effect. The botanical name for the lotus leaf is Nelumbo nucifera. The water repellent surface of the lotus leaf and flower is due to the nano-sized wax papillae which is present on the upper side of the each epidermis cell. So when raindrops comes in contact with the surface of the leaves, there are these nano-sized papillae are narrow and gaps are present in between them which hold the water molecules in mid-air. So since it is holding in the mid-air, so it is making a great contact angle. Since the contact angle is more, the friction is also more, so which makes the surface which makes the water molecule to carry away the dust and dirt particles and leaving the surface clean. So this self-cleaning property was first discovered by the professor Wilhelm Bartholdt. He is the director of the Botanical Garden of University of Bonn, and he also got patent for this lotus leaf effect on 1980s. So there are lots of applications of this lotus leaf effect, and this self-cleaning property of the lotus leaf is mainly due to the hydrophobic surfaces. So it is mainly on the hydrophobic surfaces, there is water repellent surfaces. So it is termed as a lotus wick and a lotus effect, and it has opened many applications in various fields in nanotechnology. So while seeing the hydrophobic surfaces, so in rough surfaces, that is hydrophobic surfaces, so this is a simple mechanism that how a water molecule is dragging away these dragging away the dirt particles around the rough surfaces. Here the contact angle is more, and for super hydrophobic surfaces the contact angle is greater than 150 degree, and for hydrophobic surfaces the contact angle is in the range of 150 to 90 degree. For hydrophilic water loving surfaces, that is its contact angle is 90 to 10 degrees, and super hydrophilic surfaces for contact angle is 10 to 0 degree. So there are various applications in lotus leaf effect. It is used in various fields like in microwave antennas to reduce the moisture, ice, snow, and since it is having an optimizing water repellency, so it is used in non-wettable rainwater and salts and boats, and paints. It is used also used in paints for kitchen roofs and walls for the soot-free, and it is used as a water repellent fibers for garment, etc. And self-cleaning glass installed in the traffic control units, and many other applications of use in this lotus leaf. Moving on to the next natural nanomaterial is the butterfly wings. So butterfly wings, here we are going to discuss about 2 butterflies. First one is the Greta Otto butterfly. This Greta butterfly is also called as the glass-winged butterfly. It belongs to the tribe Ithomini tribe. So these butterflies are naturally transparent in nature. Any object or any organisms or any tissues, if it want to be transparent in nature, it must be non-absorbing and non-scattering. So this surface of this Greto-Otto butterfly or glass-winged butterfly is covered with a sub-microscopic protrusion which do not scatter light. So this is why no scattering of light takes place, and moreover, the index of refraction is gradually changed over the protrusion from an index matching of the air to the index matching to the material of the wing, similar what we see in the glass. Moreover, it has a highly destructive interference present in it, so that no scattering of light takes place in this Greto-Otto butterfly. Another application of butterfly wings is that butterfly wings are also famous for its brilliant iridescent colors. That is, it has due bright colors. So these colors these color giving a butterfly is the best example is called as a morpho butterfly. This morpho butterfly is having a photonic nanostructures on the scales and its ridges. So it also having many multifunctional characteristics like a morpho butterfly wing scales, including lightweight, visual effects, hydrophobicity, and mechanically strong and thermal regulations are revealed and have a relationship with the photonic structures in the ridges and the scales. So we're coming to the applications. So the butterfly architects by using these butterfly wings have inspired fabrication of sensors of energy materials by replicating their unique nanostructures present in the butterfly, like light trapping mechanisms and selective response to external stimuli. These bio-inspired sensors and energy materials have shown improved performance in harnessing renewable energy. Environmental remediation and health monitoring the nanostructures of butterfly wings unlock the potential of this to implant, making it practical, and even it is helpful for the glaucoma patients to test their own eye pressure every day with the help of this applications using the butterfly wings in the morpho butterfly. Moving on to the next natural nanomaterial is our cadmium sulfate particle. So cadmium sulfate particle, these are the nanomaterials crystalline in nature with size 20 to 40 mm in nature. In nanometer. So the stability of the nanoparticles was due to the protein interaction. Yes, this cadmium sulfate CDS is acting as a very good capping agent. Capping agent is nothing but it is having polar head and a non-polar head with hydrocarbon tail, so which making them both hydrophilic and hydrophobic in nature. So cadmium sulfate in conclude is an amphiphilic substance in nature. So this cadmium sulfate is from the synthesis from the precursor of a bacteria called as Bacillus licheniformis. So this Bacillus licheniformis bacteria is found in the soils, bird feathers, and black plumage. So in cadmium sulfate, the cadmium 2+ ions from the particles play a very important role as a cytotoxic activity of the cadmium nanoparticles. Due to the small size, the surface area of more, so the exposure of the cadmium 2+ activity on the other microbial activity, other microbes is also more. So this cadmium sulfate is playing a very important applications in antimicrobial treatment. Coming to the application, the cadmium sulfate nanoparticles are used widely for cancer diagnosis and antimicrobial treatment. So cadmium sulfate nanoparticles have proven antimicrobial properties against both gram-positive and negative, showing broad spectrum antibacterial potential, etc. So however, assessment of this toxicity is extremely important, but while they in present studies has revealed that the cadmium sulfate nanoparticles are synthesized by green and eco-friendly particle, and it is not toxic in nature. Moving on to the next natural nanomaterial as volcanic ash. So these volcanic ash is formed from the erosion and volcanic eruptions in natural, and these volcanic ash is the virgin for natural nanoparticles. So the ashes that are released during volcanic eruptions can reach a temperature that can exceed more than 1400 degrees centigrade. These ashes reach the atmosphere and neighboring water supplies, and their chemical interaction with the environment can result in the deposition of wide range of nanoparticles. So these particles typically range from the size of 100 to 200 nanometers in diameter and will be readily suspended in the air and can be easily present in the soil. It is also useful for many other microorganisms like Schonmella and Lactobacillus species for helping in their own processes by using the nanoparticles present in this volcanic ash. So there are a lot more applications in volcanic ashes. So volcanic ash having more number of nanoparticles which is highly nutrient in nature. So it is acting as a very good fertilizer for the soil, and the volcanic ash is extremely rich in minerals and has an antiseptic, antibacterial, and antioxidant nutrition properties in the soil. Because of the nanoparticles present in them, it provides more antiseptic, antibacterial, antioxidant properties in the soil. And the volcanic eruption produces a large amount of ash and pyroclastic material which contain nutrients for life in soil. And like everything have a good and bad side. This volcanic is also having a bad side, like it also sometimes can produce some toxic elements like metalloids and some metalloids, which is very harmful to our body. So moving on to the conclusion, so natural nanomaterials obtained in a way in which is very useful in medicine, agriculture, and other fields in nanotechnology and engineering. So not surprisingly, these natural nanomaterials has provided very increasing applications in our day-to-day life. And large number of researchers and nanotechnology is proving that nanotechnology is coming one of the emerging and very good technology coming in this day-to-day life. So it is now a time for our young generation like me to take stock and to anticipate some of the most exciting developments in natural nanomaterials within the next couple of years.
Okay, thank you, ma'am. Thank you for your presentation. Any questions?
Thank you, sir.
Thank you. Any questions from participants or chairpersons? This is the last presentation of oral and as well as poster presentation. Any questions? Okay. I'm going to conclude the morning session now. Judgment prevent us from seeing the good that lies beyond the appearances. The juries are our judges of all the fact and of law when they choose it. I especially thanks our chairpersons, Dr. M. Balaji and Dr. Sakti Pandi, because they're sparing their time with us from the morning to till now, and they did their job very well. And thank you for both chairpersons. Thank you so much, sir, for sparing time with us. Thank you so much. Thank you all the participants, those who are presented oral and courses. Thank you so much.
Thank you, sir. Thank you for this opportunity.
Thank you, sir. And thank you so much. Then I will start. The session is continue. The technical session 4, it is continue now. As we gain more knowledge about materials and processes in the universe, that could open up benefits that we can't even imagine in our lifetime. But you have to be willing to fund science without knowledge of the benefits. I am very delighted and I have a privilege to welcome our today's chief guest, a distinguished person, Dr. A. Chandra Bose, Associate Professor in National Institute of Technology, Tiruchirappalli. I welcome you, sir, for this afternoon session of the conference. I welcome you. Once again, I'm happy to welcome all the participants for our the afternoon session of the second day conference. I welcome you all. Now, I would like to welcome Mr. C. Ravi to introduce our chief guest.
So very good afternoon to all. It's a great pleasure to me to introduce today's chief guest, Dr. A. Chandra Bose, Assistant Professor, National Institute of Technology, Tiruchirappalli. So Dr. A. Chandra Bose received his PhD in the area of nanocrystalline material from University of Madras in the year of 2002. Then he pursued his postdoctoral research in the National Institute of Advanced Industrial Science and Technology and the National Institute for Materials Science, Japan from 2002 to 2006. Then he joined as assistant professor of physics from National Institute of Technology, Tiruchirappalli, in 2006. So the main area of his research is preparing various nanomaterial for the clean environment and sustainable energy conversion and storage applications. So he focused on the materials like metal oxides, 2D materials for photocatalytes, electrochemical capacitors, and solar cells. And he published nearly 140 research articles in high impact factor, SA and Scopus Index journals. And he delivered more than 75 invited talks in various national, international, and workshop, symposium, conference, etc. And he received many fellowship and awards, particularly Young Research Award and Young Scientist Award, Senior Research Fellow from the CSR Laboratory, and Best Teacher Award in the NIT, and Young Achiever Award. These are some awards and fellowship he received. And nearly he completed 5 research scholars under his supervisions, and presently 5 students are guiding under his supervision. So with these few words, I would like to invite our chief guest today, Dr. A. Chandrabose, to deliver the second session of today. Sir.
Yeah, good afternoon. Can you able to hear?
Yes, sir. Your voice is audible, sir.
Okay, first I will share, then we will start.
Okay.
Yeah, can you able to see the? Yeah, can you able to see?
Yes, sir.
Okay.
We can able to see, sir.
Thank you. Thank you for your nice introduction about me. I am happy to participate in the International E-Conference on Advanced Materials Science conducted by Vivekananda College of Arts and Science for Women. This is not a first time. Maybe this is the first time in online. Maybe 2 years before, I also came to the college and I delivered the lecture for your conference also. I thank organizers, particularly physics department faculty, for giving me the opportunity to present some of our recent works for the audience. Maybe the audience is like students and MSc students and other people, I think. Is it okay? Hello?
Yes, sir.
Yes, yes.
Okay, sir. Okay.
So last time I presented in your college, then one of your students joined in our college as a PhD scholar last year. So that was my success in the last visit also. So before going into the topic, I will tell about some PhD program and our MSc program also. So we are conducting a MSc as well as PhD program in our department, physics department. And if you want to join PhD program, previously we had a non-stipendary scheme. There you can join without GATE or CSIR fellowship, you can join. But now they restricted the non-stipendary scheme. So there is no opening for non-stipendary scheme. So only if you want to join in NIT, because these are all IITs and NITs are premier institutes. So if you are studying in this institute, so your future will be best opportunity. You will have a best opportunity in near future also. So in that sense, so whether you can study any one of the programs like MSc or PhD program in our institute. PhD only through GATE as well as CSIR, you can enter into the NIT scheme. For MSc also, we are conducting a MSc Physics in our department. For that, you have to write the JAM exam. then you have to join the MSc program. Previously, we used to conduct our own program, our own entrance exam, and we used to take the students. Nowadays, only through JAM you can join also. There is a GATE exam or CSIR. These are all some particular month they used to conduct. Similarly, JAM also. So those who are interested to join in NIT, so you can go through the such examination and you come to the NIT. So you'll have a bright future. So I thank once again for giving me opportunities, as well as you have given one student for us also. Thank you. So now I am moving to the topic nanomaterials for energy and environmental applications. So I will, the content of my talk is like, I will give some introduction about nanomaterials and some preparation techniques, and how these materials are useful for some applications. So in that sense, I introduce the nanomaterials. Since I am the last speaker, sometimes you might have heard about these materials, nanomaterials, introduction and all. So I will go through very short form, and I don't want to repeat the same. Even if it is a repetition, maybe you can understand more also. In that sense, sometimes some of the things may be repeated. And then I will introduce two topics today. Like, one is photocatalysis. So this is it is related with the environmental issues, and another one is a supercapacitor. This is related with the energy materials. Then after that, I will give some results as well as some examples also. Then I will conclude my session. This is the plan of talk today. So as you know, you have a you might have heard about nanoscience and nanotechnology. This word is nowadays, it is very famous. Okay, even if you are buying washing machine or any car, as well as wherever you want to see, you can see the word nano. So as a science students or as a engineering students, you should know, so what is the nanoscience and what is the nanotechnology. So in that sense, so nanoscience is the study of properties of the matter in nanoscale. So if you are deriving some something which is smaller scale, if you are studying their properties, then we call it as a nanoscience. So if you are able to, technology, what is technology? It's a science, scientific knowledge which can be applied in a practical form. That is called nanotechnology. If it is this application is in a small scale, okay, extremely small scale, then we call it as a nanotechnology. Okay, that is the way we can define this. And these things already exist in nature. Okay, that is the one. So if you want to say very concisely, so control and manipulation of matter at the nanometer range, we call it as nanoscience and nanotechnology. Okay, but these things are available in nature itself. But what we are observing from the nature is a very very primitive one. That means we are at the starting stage, because nature had made it very long back. So it is well refined form. So it is difficult to beat the nature. Okay, I can give some examples so that you can understand how the nature has a better things. Even man had a man made many things also, which is not uncomparable with nature. Okay, so for example, first I will tell photosynthesis. Okay, so no one has reached the efficiency of photosynthesis in storing energy. Okay, so that is a beautiful system. Okay, and also no one has reached, okay, the energy transfer of biomolecules. Okay, so these are all the some of the examples. Okay, the nature had its own and it has the highest efficiency also. But I can give you what man-made thing. For example, you are making some internal combustion engine. Okay, so which can give a maximum efficiency of 50%. Okay, so that in that sense, so if you understand the nature, okay, properly, then you can create the best system out of them. I can give some more examples like it. So no factories does the water purification like coconut tree or watermelon. Okay, you can get the pure water as well as it can be stored in a best way. But what we are making like a RO system and all, it is not as equivalent as this nature made it. Okay, that's the way one cannot. So if you want to understand those things, okay, so if you understand the nature and you can create the similar things also. Okay, similarly, one cannot replace the human brain with the computer. Okay, so human brain can take decision and store plenty of information from the birth to death. Okay, so a lot of information it can be stored, but the computer chip, it has limitations. So it is, and also, so if you want to make a computer chip, so you have to start with sand to make into silicon form. So you are also polluting the environment also. So whatever we are making, so that also pollute the environment also. Okay, but nature, whatever it is making, so there is no harm in the environment. Similarly, you can see the movie camera with one cannot compare movie camera with the human eye also. Similarly, one more example is like a olfactory system of dog, which is more sensitive than the whatever man-made sensors also. Okay, we have an array of sensors, plenty of sensors we made it, but one cannot replace the olfactory system of dog. Still, people are using dog as an agent. Okay, detective agent. So that is the way. So, but so so two things I wanted to tell. So you can learn many things from nature. Okay, you can mimic some of the things and you can create it, and you can make it also. That is the one thing you can make it. The another thing is whatever the technology which you are making, which should not pollute the environment also. These two things you should be very careful. So if you are polluting the environment or if you are disturbing the environment, then we have to face the many consequences from the nature also. Okay, that is the things you have to keep in mind, and you can develop this new field like nanoscience and nanotechnology. So this one, this is a very famous one, lotus leaves. So you might have heard someone's speech also. Okay, this is if you pour water on the leaves, so it won't touch us on the surface. Okay, it will comes down or it rolls down easily. But if you want to, so what is interesting things in that? So if you see the scanning electron microscope, you wanted to see what is inside the leaves. So if you do the scanning electron microscope, you can see the similar kind of a structure. Okay, this is a kind of a whisker structures inside the lotus leaves. So which is in the form of micro and nano architectures. Okay, so small and big size of things. These kind of micro and nano structures, so which can minimize the droplet adhesion to the surface. Okay, that's why. So whatever the things, if you are pouring, so that can comes down very quickly also. Okay, so that's a way. If you can similar things you can make also. Okay, there are people studied these things and they also created many applications based on the lotus leaves activity. Okay, so if you want to study the nanomaterials or nanotechnology, if you want to have you should have an interdisciplinary mind. Okay, for example, if you are a physics person, so you wanted to do some synthesis, then you need some chemistry knowledge. So you want to do some sensors, so you need some biological knowledge. So you want to do some machinery things, so you need some engineering. Or you wanted to do some calculations, okay, simulations, then you need some mathematical knowledge. So it is difficult to acquire all kinds of knowledge in a particular field person. Okay, so if you want to work on the nanotechnology, so you can collaborate with other disciplinary people, and you can bring the best applications out of them. Okay, For example, you can study, you can characterize your material and everything, but if you go for some applications, you need some people expertise also. Okay, in that sense, it is an interdisciplinary field. This is also a very famous statement by Richard Feynman. There is a room at the bottom. He made this statement in some conference lecture. He made it. So the meaning is, so a small pinhead size, you can store the plenty of information on them. Okay, that is the things he tell also. And also he told this can be stored in the form of bits. Okay, zeros and one. This was predicted in 1959. Okay, so that's that time we don't have any modern technology also. So that time itself he predicted, and it has come true also. Okay, now we have small pen drive, so you can be able to store plenty of information inside. So those kind of things comes true after 50-40 years later because of the nanotechnology. Yeah. So now I will go for the introduce the materials. So what is nanomaterials? Okay, people used to define like 100, less than 100 nanometers, or less than this, like that. People design tell the definition of nanomaterials. So normally polycrystals with grain size in the nanometer range, less than 50 nanometer. That's we call it as a nanomaterials. So normally any material, so you have a grain and grain boundaries. Okay, grain means a group of atoms oriented in a particular direction. Grain boundary means these grains in between there is a boundaries. So there we call it as a grain boundaries. Okay, I can show you some pictures so that you can understand very clearly. So when the grain size is smaller, grain means it's a group of atom oriented in particular, or some kind of a cluster or some kind of a group which are all having the same orientation. Okay, maybe you can call it as the same group of mindset people gathered together, similar like that. The material also it has. And if the size is very small, so you can have a more number of people, more number of atoms are in the grain boundaries. Okay, so that is the things they found it. And also when the properties also changes with respect to the grain size. Okay, when the grain size changes, accordingly the properties also changes. We will see what is that. Okay, now you can see the pictorial representation. In a x-axis the grain size, and y-axis the percentage of grain boundaries. Okay, so when the grain size, for example, you have 100 nanometer the grain size. Okay, the 100 nanometer, you have a less number of atom in the grain boundaries. Okay, I can mark a line. It's very small percentage. Okay, but when you reduce the size like 10 nanometers, so you have more number of atom in the grain boundaries. So when the size is very small, so you can accommodate more number of atom in the boundaries. Okay, so if you want to see the grain and grain boundaries, you need a high resolution transmission electron microscopy one. So this picture is the right side one. Okay, so this right side one, it's a TEM picture, high resolution TEM image. So there it's a palladium particle. Okay, nanophase particle. So you can see these are all the lattice. Lattice is nothing but the group of atoms. Okay, you are seeing the atoms. Okay, how the atoms are ordered in the one. So that one we call the grain. And there is another one which is oriented in a different direction. So that's why it's called polycrystals. Okay, if it is oriented in a single way, it's called single crystals. These are oriented in a different direction, so we call it the polycrystal. So here you can see some of the atoms are in between these grains also. These one we call the grain boundaries. Okay, so because of these kind of variations in the grain and grain boundaries, so material has a peculiar properties when compared with the bulk form. Bulk means, so it's I will tell you a little later. Okay, so I can give you one example why it is interesting. Okay, you have one cube. Okay, 1 centimeter cube with gold. Okay, so in that, how many number of atoms which is represented here? and how many number of atom outside it is also represented. Okay, so if you calculate the ratio, then you have only small percentage of atom in the outside. Okay, so but when you are reducing the size, okay, you are cutting these cubes into smaller. For example, you made it as a 100 nanometer. There you can see 1.5% of atom in the outside. Okay, now you can reduce still further. So like 3 nanometer or 1 nanometer. So you can find the more number of atoms are outside. So what is the interesting thing? If it is more number of atoms are outside, so that can be used for many applications. Okay, easily you can like if you want to make a sensors, more number of atoms are outside, so you can easily use for some sensing applications like that. So if it is more number of atoms are outside, so it can be exposed easily when compared with the atoms inside the core. Okay, that's a thing. That's why these materials are very interesting. So you might be knowing that one example like a sugar in the form of cube and sugar in the form of powder. So if you put both things, which one can do it in a very faster, which one can be dissolved in a faster way. So you can understand while doing the one. Okay, so why these materials are nanomaterials are very interesting. There are it is completely different from bulk. Bulk means it's the grain size which is in a micron size. Okay, nanomaterials means it is in the nanometer size. Okay, so that's a difference. So so it is you can tell in the words like 1,000 times smaller than the normal material. So we can call it as a nanomaterials. So what is interesting is large fractions of atom on the surface. That's what we have shown. And if more number of atom on the surface, so you can have a surface energy is very high. So you can easily interact with the other materials. Or if it is a spatially confined also, so you can in this material you can make a material in the form of 1-dimensional or 2-dimensional or 3-dimensional form. You can make it also. So if it is a 1-dimensional, then the movement of electrons is confined in a 1-dimensional way, so that whatever the property in bulk, which is different from the in a other way. Okay. So in this so these nanomaterials are entirely different. Okay. So why when the size is very small, so what are all the properties will change? Okay, thermal properties, the melting point gets changed, as well as mechanical properties or optical, electrical, magnetic properties. Everything is different from the bulk materials. Not only different, you can also in the sense you have an enhanced properties also. That's why people are interested. Okay? Sometimes you can tailor the properties. For example, you take optical properties. So you might have studied the band gap of the material is a constant. But when you reduce the size of the material, so you can change the band gap of the material, so that whatever the absorption or emission, which can be different. For example, if it is bulk form, when it is emitting the yellow color means, but when you convert it into band gap higher, then it can emit sometimes a higher wavelength or lower wavelength, according depending upon your material also. This can be done. Okay, in that sense, these once you are getting enhanced, as well as you can tailor the material, what kind of a light emission you wanted to do. So you can tailor your material, same material, but you can tailor it according to your applications. That's why these nanomaterials are very interesting. So I can give you one example like a melting temperature. When the size decreases, the surface energy increases, the melting point decreases. For example, you take a cadmium selenide. When it is in a bulk form, so it has a melting point of 1678. But when it is in the small form, smaller grain size like 3 nanometer cadmium selenide nanocrystals, so it melted 700 Kelvin itself. Okay, so completely reduced. Okay, so you can easily melt it and you can make the things easily. Or sometimes people wanted to make some alloys. So during the time when you reduce the size, so you can easily mix this material and you can make a best material at a lower temperature itself. So that is the advantage of this material. So now, okay, sorry. It is repeated one more time. Okay. So what is the difference between micro and nanomaterials? So this is a scanning electron microscope pictures. So there it is taken in the same scale. Okay. So 15 micrometer this scale, and this also 15 micrometer. When it is a microcrystals or bulk material, so you can see the grains in a very big way. And if it is a nanomaterial, same one, if it is form of nanomaterial, it looks like a dot. Okay. But if you want to see the similar one, so you have to go for the high resolution electron microscope. There you can see the grain and grain boundaries there. So it is 1,000 times smaller than the microcrystalline materials. So it has some interesting and properties. So how to prepare these material? So there are two approaches generally, like top down and bottom up. You might have heard about this also. Starting from bulk to smaller size into nano. So we call this a top down, and bottom up means so you can have atom by atom and you can construct the nano size materials also. So there are different types of preparation techniques are available. Like for top down, you can do mechanical milling, like it's a grinding material, or you can go for the magnetron sputtering or evaporation techniques. These are the materials. It has a bulk form, then you can evaporate and you can make a thin film form. Similarly, in chemical methods or other electrode deposition method, you can start with the atom and you can making a nano sized particle also. Okay, that's the way one can. These are two broad approaches. So when you want to prepare the nanomaterials, there are plenty of techniques available. I have listed very few. So chemical methods, inert gas condensation, microplasma, mechanical alloying, sputtering. So there are plenty of methods. So depending upon your environment, you can adapt any one of the techniques and you can prepare the nanomaterials for some applications. Okay, I can give you two examples. One is chemical methods and inert gas condensation method, so that you can understand how easily you can prepare the material, as well as how costlier material methods also available for preparation. That also you can understand. So this method is called so this is called co-precipitation technique. So in this one can prepare the oxide materials easily. So it's a kind of a chemical method. So you can use, so when you want to make any chemical methods, if you are adapting, then you can take some materials like precursors. It's nothing but a starting material. Like you want to make some metal oxides. So you can make metal chlorides or metal nitrates you can take in particular form. Then you have to do hydrolysis. Okay. So if you have a conical flask and if you have a heater and you have a condenser arrangement, so you can easily prepare the material. Okay. So what you have to do is, so you have to take a precursors, then you have to hydrolyze. Hydrolyze means so you can heat the material. It is in the form of water mixed with these metal precursors. Then you have to heat it and it goes up and condense. And after if it is in the watery form initially, then after that this will form a colloidal solution. When you measure the pH of this one, you can found it is in acidic in nature. Then if you add ammonia, then this will form a precipitation. Then you can wash and dry and you can get the powder. Okay, you can easily prepare. But any methods, so you have some parameters you can control and you can prepare the material in a particular form also. Like you wanted to have a less grain size, so you can do hydrolysis for several hours and you can make it in a smaller grain size also. Like that, you can play with some of the parameters and you can make the best material out of them also. So for them you have to make some trial and error and you can make it also. So very simple one. Okay, anybody can adopt and you can prepare the material even in a college or any in home also you can make it if you have a similar setup in your one. So there is another method called inert gas condensation technique. Here you need some vacuum chambers and vacuum pumps and everything is required. So here you have a ultra high vacuum chamber. Ultra high vacuum means the vacuum is of the order of 10⁻⁷ torr. Okay, so that one -7 torr means atmospheric the pressure is around 760 torr. So whatever we are living is around 760 torr. So you have to come down in a 10 power minus 8 torr. So that means 0.000 something torr you have to make it, so that you can prepare the material in a pure form. For example, you wanted to make a metal, so you can adopt this one and you can make the material in this form also. Here there are two, the first image, okay, there you have a chamber and something below the chamber, some arrangement is there. So the below the chamber some arrangement which is shown in a different form also. The chamber is used for preparation of nanomaterials. The below the chamber which is used for making some pellet form. Okay, there are two parts mainly. So if you open this chamber, you can see the right side figure. There you can see the some evaporation source, scraper, funnel, and many pumps are there. Okay, so pumps, the ports are, you can see. So if you want to make any material, you put the material inside and you can close it, and you have to produce a ultra high vacuum pressure. Okay, so that means so you have to spend a day or more than a day or 2 days continuously, so that you can reach the ultra high vacuum. So after that you have to put some inert gas inside one. So this one is called like a cold finger. So this cold finger is filled with liquid nitrogen. Okay. So once it is liquid nitrogen, means that the temperature is around 77 Kelvin, very low temperature, and here there is a evaporation source. Okay, this so whenever after creating a low pressure, so you can evaporate the material by resistive heating. Okay, you give the current and you can make the boat into heat, and your material gets evaporated. And since this temperature difference, so automatically it go and deposit on the cold finger. So once the material is deposited, okay, there is a before that there is a inert gas, your argon pressure inside. So whatever the evaporated atoms which we go and exchange the interaction with this inert gas and go and deposit it. Okay, since there is a difference in the temperature, so automatically it deposited on the cold finger and it condenses. So you can make a material in a very small size also. And once it is deposited completely, so you can put the scraper and the material fell down through the funnel, and this can be collected the below the chamber one. This is called compaction unit, this one. Then there is a die arrangement inside. Okay, so whatever the one compaction unit, the right side, so there is a die arrangement. So you can collect the powder and you can put the pressure, hydraulic pressure, and you can compact, and you can make a pellet in a everything you can make it in the vacuum itself. So this method is called the inert gas condensation method. Here also there are what is the inert gas pressure you are filled inside, and what kind of evaporation rate you are making. Everything you can decide what is the size of your material. Okay, for example, if you want to make any metal powder, so you can make it inside itself, vacuum itself, so that it is not get oxidized easily. Okay, so you can get a pure metal powder out of this technique. Not only metal, you can make a oxide material also. So you can, if you have other type of gases, so you can make a different types of material inside itself. It may be in the powder form, or sometimes you can make a preparation in the thin film form also. Okay, this chamber mainly for powder form, and you can make the material. So if you want to make this kind of, if you have this kind of arrangement, you need at least more than ₹1 crore, and you have to continuously work in this chamber, and you have to make it. Okay, this is another technique. So I introduce a simple technique as well as costlier technique to you. So while evaporation, you can see how much temperature inside, those can be identified through the viewports also, and how the material is deposited inside the cold finger, that can be viewed also. So after deposition, it become black color, then you can scrap and remove the material also. So everything you can do it in a vacuum cell. So that's the thing. So now we will move on to the so now you assume that you have prepared some materials. So Particularly, I worked on oxide materials because it is a very, you can easily prepare these nanomaterials. And also it has plenty of potential applications like fuel cells or catalytic or luminescence, gas sensors, electrode materials, like plenty of applications with these oxide material also. And also you can, as I told you, you can easily prepare like co-precipitation or sol gel or hydrothermal. Any one of the methods you can adapt and you can prepare the material also. And also you can have a control over the grain size and shape of the material, so that you can have a different, you can get out of the different properties of the atom. So once you prepared a particular material and you have to study the some of the properties, structural, electrical, optical, or depending upon the nature of the material, so you can do some property studies. Then after studying the properties, so you can go for some applications. So that's a way you can go to the material also. So now we are going to study about the environmental related issues. So first one is this is the air pollution. Okay, you might be knowing that Delhi is a very known place for air pollution. So the safety limit of good air is around 100 microgram per meter cube. So if it is the dust which is within the limit, okay, you are safe. Okay, that means so you don't have any harm in your body. Okay, but if the limit exceeds, okay, then you will have a problem. Okay, on the day of Diwali, how much the 1680 microgram per meter cube. That means so you have it is completely polluted. And if you have some lungs problem or breathing problem, then you will have it is difficult to breathe this air. Okay, these are all done by some government agencies there, like a system of air quality and weather forecasting and research. Okay, these they can announce whether this quality of air is good or bad or moderate, like that they used to give. Particularly some of the places like a particular time or some places you will have it is above the safety limit, so you should take care of the one. That's why nowadays you might be knowing that the vehicles and all they are from Bharat 4 to 6, like that there are some limitations. These are all the based on the this kind of a data, they are moving into the clean and healthy environment. But we are not going to discuss this one. Okay, this is the one example. So now our discussion is on the wastewater pollutant. Okay, wastewater, how to treat the wastewater. Particularly this waste, the pollutants are dyes mostly, and you have a major source of this pollutant is from dye, and it has a more than 30,000 commercial dyes are available, and it is in a different chemical form also. But these are all used by the textile industry, food or plastic or paper, pharmaceutical, leather industries. Okay, so whatever the industries, sometimes they use a dye. So after that, what is the problem? Okay, so after usage of dye, this can be not properly drained into the water stream. That is the problem. Okay, actually, as per the norm, you should after process. Okay, this can be processed properly, and you can remove the dye, and then it can be sent out. But many of the places this is not followed, and whatever the dye which is directly come from the industries, and this can be channelized into the stream, water streams like a river or a sea, like that it can be mingled inside the water streams. So what will happen after some time? So if it is a land water also get polluted, and river water as well as sea water also get polluted. So once it is get polluted, then the aquatic lives like fish or other things get also affected. So this will affect the whole environment also. So if you are drinking this water, what will happen? You can see your health will be severely affected. And if you are eating this kind of fish or this kind of aquatic things, then you will have a problem. Okay, that's why. So whatever the things which you are creating, whatever the comfort you are making, that should not affect the environment. That's the way you should have create some awareness among the people. So that's the way we can do it. So for that, what we can do, how to avoid these things. So everybody is looking for a clean and healthy environment, but people are not aware of how to make the one. So there are dye. So we are particularly water pollution in dye removals. There are plenty of techniques like coagulation, membrane separation, electrochemical treatment. There are plenty of techniques available to remove the dye, but now we are going to discuss about the photocatalysis. So you may be knowing that catalyst means accelerating any reaction. That way it's called catalyst. If it is a photocatalyst means when you are using the light, so you can increase the reaction rate. So that's the way this can be defined. And when you want to mostly semiconductor materials are used like a photocatalyst. Okay, in the photocatalysis process, you can use a semiconductor material. Why it is interesting means high efficiency. As I told you, you can easily prepare this material, and also it is cheaper. So that's a sense you can use a semiconductor material. So this photocatalyst was famous after discovery of water photo electrolysis with DiO2 material by Fukushima and Honda in the year of 1971. What they have done is they split the water into hydrogen and oxygen in a photoelectrochemical cell. Then after that, this field was introduced like a photocatalysis. Okay. So what is the as you know, you are all know about the semiconductor materials. It has a valence band and conduction band, and you have a band gap. So when the light falls on the material, particular energy, the sufficient energy is given, then the electrons move from valence band to conduction band. So once the electron moves means it creates the holes on the valence band, and these electrons and holes are the main agent. Okay, so these holes can be used directly for some oxidation or reduction purpose. These electrons also go and do some oxidation reduction reaction. That's called redox reactions. So these formed holes and electrons, so which can be used for redox reactions. Then these redox based on this one, this can be interact with the dye, and this can remove the dye from the water. Okay, that's the way this is working. That's called photocatalysis. The light, using light, so you are doing redox reactions. That's why it's called photocatalysis. Okay, so once how to develop this material? So people started with the TiO2 because this is abundant and toxicity is less, fast absorption, similar kind of some material properties it has. So started with one. As you know, the TiO2 band gap is 3.2. So this is not lie in the visible region. So it is in the UV region. So whatever the sunlight, many people, they wanted to use the sunlight as a photo agent. So only 4% of the solar spectrum can be used. But one more problem is these electron hole pair recombination process also possible. So once whatever the electron hole produced, this can be combined easily also. So that time this is not useful. For example, if you are using LED or laser, so these electron hole combinations are required. But here it is not required. This electron hole combination should not happen. So for that, what we can do, like that, this material can be designed. So even though TiO2 has many advantages, but there are some disadvantages like band gap as well as these electron hole recombinations. People started thinking of other materials like zinc oxide, tungsten oxide, other oxide materials. But even then, there are some problem or not, the efficiency is not up to the level. So people started doping the material. The second form is doping the material so that you can create some, even though TiO2 is not a UV, not visible region, but if you dope this material, with some elements, so that you can create a donor and acceptor level in between, so that it can be visible light driven kind of a things. So you can dope the material, or you can make a two-phase materials, so that you can change the this kind of electron hole pair combinations can be also avoided. So these kind of things people started working on that. So mainly you should think of, so your charge transfer done in a proper way, otherwise the electron hole recombinations may happen, so then it is not 100% efficiency. So what is the way one can started with single material, then they use a doped system, or sometimes people use the co-catalyst also. So you have a main system of oxides, then you can use platinum as a co-catalyst, so that you can reduce the, so you can introduce the trapping sites inside. So this can be like a use like a active sites. Okay, so this some transfer of electron to the co-catalyst, and it can avoid the recombinations. So like that you can do something, and you can make the material in a efficient way. And also, so you can use some composite system. Okay, both material can be visible light, or sometimes one may be visible light, or one may be in other band gap of the material. So like that you can design the material. And one more interesting thing is, in a mechanism A, both material can be involved in the catalyst, photocatalyst, or sometimes one of the material may be used for a photocatalyst, and other may be do the some charge transfer process, like that they can handle also. So like that you can design the material. Okay, so material has some nature, but you can modify the material according to our requirement. So like that you can do it also. So when you want to work on the designing the visible light photocatalyst, so these are all things you should keep in mind. Like band gap of the material is very important. Electron hole recombination should be avoided. Stable under light irradiations, and surface nature. Okay, that's why the nanomaterial has come. So if you have a very small in size, so you have more number of atoms in the surface, it may be active for reactions, so it may be useful. So likewise, you can think of the efficient charge transport mechanism also. So how to avoid the electron hole recombination. So these are all the things keep in mind, and you can design the photocatalyst. So we started with the silver phosphate. I'm not going into the full detail of the one. I can tell you how to approach and how to design the material like that, very general way also. Okay, so for example, this material band gap is 2.5, so it's a very within the limit of visible light. And your photocatalytic dye degradation, you can use this material, or photocatalytic oxygen evolution, or antibacterial, like that. This material can be studied also. So if you want to do any do research, so you need some literature. Literature is very important also. So in that, so you have to find some base for your progress. So in that, we found some material around 2010, Nature Materials, High Impact Factor journal. There this material was studied, and we started doing this material also. And we also prepared this material into different methods, like ion exchange method as well as hydrothermal method. This is not I discussed, but we have adapted these techniques, and we prepared the material also. Then the same material can be subjected for photocatalyst degradation, and you need not bother about these graph and all. Okay, so once you want to work on this one, you can easily understand, like this degradation efficiency can be calculated, like some formula is there. This is C0 is the initial concentration, and the CT is the residual concentration. Like that you can calculate how much it is degraded, like that you can find it also. We also use a dye like a methyl blue as a dye, methylene blue as a dye. There this also used in the some textile industries also. So we adopted, and we found that the ion exchange method shows the better results when compared with the other hydrothermal method. So around this, around 100 and 120 minutes to remove the dye according to the different concentration also we took. Okay, 25 microgram, 50 microgram, like that. We have taken in a different concentration and we did the photo degradation. Finally, we found that ion exchange method is the best one. And after that also, what you are doing, how the charge transfer is taking place, like that you can give also. So holes created as well as oxygen also, the electrons also goes in the conduction band, and these electrons which will convert the produce the oxygen radicals in that. Okay, so this oxygen radical as well as these holes are used for dye degradation. Okay, directly this will convert the chemical structure into normal one. Okay, that's the way it is doing. So once you have material is produced, so you should know what is the stability of our material after degradation, how this material is stable. So those things you have to do. So for that you can do the X-ray, XRD studies. Okay, X-ray X-ray spectroscopy you can do. And so we found that some changes. Okay, so after degradation, so we found some AG formation in the material we found. Okay, that means it's not so stable. Some AG formation due to the reduction also happening. So this also not useful, and the efficiency also is not so high. So we can think of other material. So we thought of going with the composite form. So for that we have chosen another material called Ag2MO4. It's also strong oxidation potential, and this can be make a combine. And when you want to make any material, first prepare the material, then you can do some basic properties like XRD, scanning electron microscope, and other things also. So same way we have made it with a different percentage, 5, 10, 15%, 8%. We have added the Ag2MO4, and when the Ag2MO4 concentration is more, there you can find that Ag2MO4 peaks are more predominant in the XRD, and we confirm that the phase of the material also through XRD. Okay, X-ray is mainly useful for to know the structural studies. Then you can go for the scanning electron microscope. We prepare the material in a pure form like Ag3PO4, Ag2MO4, and we made the things. And we've studied, one is a spherical form and another one is a cubical form. Then when you make the composite, so we found that both things are available in the composite form. Okay, figure C shows that both it is a composite which can show the both form of a material also. So like that, after that we can, after studying some more characterization also, I didn't discuss all the things. So we can subject to the photo degradation application. So we started with methylene blue. So there with the different things also. So you can find, so methylene blue is degraded at 8 minutes, very short time. Okay, that the one which was Ag3PO4, there you can see 120 minutes. Now it is drastically come down at 8 minutes. And also whether this can be applicable for other form of dyes also, like we use rhodamine B as well as methyl orange. There also rhodamine B gave a very short time, but methyl orange you can go for 120. So what is the reason behind it? Some of the dye which can be degraded very faster, and some of the dye which can be in a very long time. So for that we made some measurements like whether the dye is cationic or anionic. Cationic means positive surface charges. Dye has a positive surface charge. So if it's a cationic dyes, it has a negative surface charges. And also your material also can be identified whether this is a cationic or anionic. In that form, the material that can be done by the zeta potential measurements, and you can find it is a negative charges. Okay, so whatever the dye in the form of cationic one, so which can be degraded in a faster way, and whatever the anionic one, which can be degraded in it takes a longer time, because so one is a positive and negative, so you have electrostatic attraction, and another one is a negative and negative, so it is a electrostatic repulsion, so it takes longer time for making the image. So you have to find, so what is the one which is do the things also. Then you have to find the another, if it is working on photocatalytic material, so you should know that what kind of scavengers like holes or oxygen radicals or OH radicals, which one is formed and which one is more responsible for dye degradation. That also you have to find it. So for that, some radical test is there. Okay. So for example, this sodium EDTA. Okay, that means ethylene diamine tetraacetate. That is, if you use that radical, that compound, that can be useful for influence of holes. Okay, that means it will absorb the holes, and if you use a test agent, and if you use other benzoquinone, okay, BSZQ is nothing but the benzoquinone, which is for oxygen radicals, and if you use a butanol, okay, butanol, okay, that can be used for OH radicals. Okay, so we use a particular concentration and we took the one, and we found that the holes are more responsible, because when you use the EDTA, it suppresses very faster way within the time of 8 minutes, so it absorbs a lot. So the holes are the main thing, and the remaining things are oxygen and other things also. So this can be we can understand which is the responsible one for the one also, and also you can study the stability, as I told you. So how many runs it can be done also, okay, whether it can be useful for several runs, or is there any limitations. For example, in our case, we have made it for same material which can be subjected for different runs. Okay, once you use the material, then you can remove the material, then again you can use for next degradation. Like that, if you go, then you can find the whether efficiencies decreases or not. We found a small decrease in the degradation rate. So that's the way one can check the how much cycle stability and what is the responsible for one also made it. And also you can do the charge transfer mechanism. Finally, you can tell it. Need not worry about that. This charge transfer mechanism table, you can make it by using, you can calculate the some valence band and conduction band edges from the some Mulliken negativity theory. You can find it, and it can be assigned in each material also, like 2.95 like that. So according to the bandage, so sometimes whatever the holes which is formed, which can be transferred according to the energy levels, and this can be directly, the holes can be used for oxidation. Similarly, whatever the electron which goes up on the conduction band, according to the energy level, this can be transferred properly, and this can be create oxygen radicals. So this can also useful for dye degradation. So like that, you can able to give the some mechanism how it can be done also. Okay, with that I will stop this material like photocatalyst. Then I will introduce another topic called electrochemical energy storage applications. So energy is the ultimate in the world. Okay, so you have a, so you can make a sorry. So whatever the country growth, which also depends upon the how much you have energy material, or how much things related with the energies which you are making in your country, that also tell about your growth of your country. And nowadays you have a more number of demand as well as consumptions are also increases exponentially. So people are thinking of whether because if you are using fossil fuels, this can be depleted in a very faster way, and after some time, okay, after 50 years, whether we will have a fossil fuels or not, we don't know. So for that, before that, we have to go for the some renewable sources, and also this can be in a green way also when compared with the fossil fuels. So now I will distinguish what is a non-renewable and renewable. So for example, oil or nuclear or natural gas or coal, These are all the non-renewable. So once you have derived it, then you may not get the things after you won't get it also, I can say. And these are all some of the things like renewable, like hydro, solar, wind, tidal, biomass. These are all some of the things renewable, and also it won't give much pollution to the environment also. So how much percentage we are using energy consumption? You can see, after seeing, you can have some idea. Okay, we have a petroleum, natural gas, coal, and nuclear. So you are using plenty of petroleum products, natural gases, coal, everything. But when you see the renewable sources, the percentage is very small. Okay, biomass only high. Okay, or solar or other form of any renewable sources are very limited. Okay, very limited. Only we are using. Okay, so that's why people are interested to do search on this material, and they wanted to switch over from this non-renewable to renewable sources. Okay, that's the background for people are interested why energy related materials are very important. As I told you, these fossils are depleted, and also sometimes these fossils are polluting the environment also because of this pollution, this global warming and other things. You might have seen in the recently in the Uttarakhand, the icebergs suddenly they come as a flood like that. There are some disaster because of the creating some pollution. So this can affect the whole environment also. That's why we should not disturb any natural things. We don't know how it can impact, and also if it is impacted, then it is difficult to afford also. Okay, that's the way people are thinking of the renewable as well as clean and renewable energies. People are thinking. So in that line, so energy storages are very important. So whatever the things which you are making, those things can be stored in a proper way. There are plenty of techniques like mechanical, thermal, electrochemical, and electromagnetic energy storages are available. So you can, we are going to discuss here about electrochemical energy storage, and particularly electrochemical energy storage. There are many types like lithium batteries, supercapacitor, and fuel cells. So we are going to see the supercapacitors, particularly we are going to discuss. So whenever any working on energy related materials, this plot is very important. We're going to plot. So this one plotted against energy density versus power density. So seeing this one, okay, batteries, so you have a high energy densities. After seeing this one, capacitors, you have a power density is very high. So supercapacitor means it's in between capacitors and batteries. So what is it has a good power density, but when compared with batteries, this has a less energy density. So people thinking that I wanted to make some improve, whether it can be improved supercapacitor energy density can be improved or not, or whether we can combine these material with batteries, like that people are trying. Okay, so in that way this field is very hot, and people are working on this material also, supercapacitor. And we can compare this with the sports item. Okay, for example, battery means for example, one person who is moving running for a marathon, he need more energy than power. Okay, so he's not going to go in a very faster way, but he need a more energy for a long run. Similarly, if you do the capacitor, if you see, so power is required for a fraction of seconds or minutes, okay, for moving into high jump. So that's the way it is related with capacitor. But supercapacitor, it requires power as well as energy also. So those who move running for a 400-meter race or some relay race kind of things. Fuel cell, as you know, so whenever there is oxygen, it can be run, and when the oxygen is gone, means it cannot be run by the run. Okay, that means so it is compared with the scuba diving. So wherever the cylinder is full, so you can be inside the water, and once it is getting reduced, then you have to come back. Okay, that's the way it is related also. Now, why we are going to study the supercapacitor? Because you have a large capacity, and also charging discharging rate is very high. Okay, So battery, as you know, battery, the charging, it takes longer time, but supercapacitor, you can do it very faster way also. And nowadays, you may be knowing that many of the future, the car and all moving into the electric vehicles. So for that, these supercapacitors and related research are very important. And also environment friendly, when you use a battery, so you have a lithium and other kind of materials. So that is a toxic one also. And also high safety, and it can be operated in a wide temperature. And one more thing, very important thing is like a long cycle life. Okay, cycling is very, very high in the supercapacitor materials. Batteries, you have more than up to 10,000 cycles, but when you supercapacitors, you can go up to 1 lakh cycles, more than 1 lakh cycles. So people already made it. Okay, some industries, maybe in the China, they made it also. So they made a supercapacitor using active carbon materials, ACAC, and also they made a trolley or a kind of a tram car, which is made up of a, like this one is made up of nickel hydroxide with active carbon materials using supercapacitors. Okay, this kind of research is going nowadays, and you can explore many things from them. Okay, based on the charge storing mechanism, so this can be divided into different one, like a EDLC, electric double layer capacitor. In that, it is similar like a physical capacitor. So physical absorption or desorption of these charges in between electrode and electrolytes. So that we call it the electric double layer capacitance. And next one is a pseudo capacitor. That means, so here mainly redox reaction is happening. The mechanism is how the charges are stored. Okay, redox, okay, oxidation and reduction process, it can be done, or sometimes intercalation or deintercalation also happening in the material. When you combine these two, EDLC as well as pseudo capacitance, those material we call as a hybrid capacitors. Okay, so that's the way this can be classified based on the storage mechanism. So when you want to make a supercapacitor, so you have to concentrate on some of the parts, like as I told you in the photocatalytic materials. Here also electrodes are very important. You can make carbon-based material, metal oxides, conducting polymers, composites. Like that, you can play with the electrode material also. Then the electrolyte are also very important. Mostly people use electrolyte kind of water and other like KOH and other kind of material also, like aqueous kind or non-aqueous kind of electrolytes can be used. So depending upon the electrolyte, so your potential window or energy density can be increased, and also surface area. So if you are making electrode, so you can make how to increase the surface area so that more material can be in an active form. Similarly, current collector, you can use different like nickel based, copper based, carbon based, like that you can use. And also binders, finally, because it can be used like a separators. Binders as well as separators also very important. So like that, you have to concentrate on the one, but mainly people started mainly on the electrode material also. So if you want to do any electrochemical related supercapacitor material, you need some electrochemical workstation with the electrochemical cell. This is a basic things required when you want to do experiment. For example, this is a kind of a continuous measurements. You cannot if you have a own machine, then you can do the research. It is not like XRD. Okay, you can give the sample and they can make it and they can do it. It's not like that. You have to run it continuously for different studies. For that, you need such a equipment so that you can do the research. Okay. So there is a comparison of these electrochemical after doing the electrochemical performance CV cycle measurements. So you can compare your material, what kind of material, whether it's a supercapacitor or battery type material also. This is also very important. Okay, if it is a supercapacitor material, okay, if you do the CV curve, this is called a CV curve. There you can see the potential curve maintains a rectangular shape. Okay, that is the one you are seeing, this one rectangular, and also nearly its current is constant. Okay, that one. So if you are getting similar kind of CV curves, So I will show you some examples later also. Then you will call it as a this is supercapacitor material. But when you want to do battery type of material, you have a like some Faradic peaks are predominant. So you can tell this material behave like a battery material. Similarly, if you two types of measurements, one is a CV curve measurements, another one is a galvanostatic charge discharge measurements. Okay, the first one I discussed. Okay, second one is based on the galvanostatic charge discharge measurements. There, if it is a supercapacitor, you can have a slope shape is very constant. Okay, you can have a rectangle. This kind of a shape. Okay, not rectangular. This one is like a charging and discharging shape with a symmetric one. So like triangular shape. So which can be which is mainly based on the supercapacitor material. But if it is a batteries, so you can have some charge. There is a difference as well as the Plato region also. So based on this study itself, you can tell whether this material is a supercapacitor or battery type material. You can distinguish also. So mainly our energy is based on the half CV squared. Okay, the formula is if you want to increase the capacitance, so you can increase the electrical conductivity, pore size, specific surface area. So if you concentrate with your material with this, so you can increase the capacitance. If you want to increase the voltage, okay, so for that you have to use the electrolyte and hybrid supercapacitor, so that you can increase the totally. Obviously, finally you are going to increase the energy. So that's the way you can plan your research also. So anyway, first we will started with the carbon, metal oxides, and conducting polymers. So based on that, one can start. So we will also start with the single phase materials. Then we go for composite and perovskites. Then some layers material also we using. Okay. So I will stop maybe. So how much time I can have? Hello. Okay, I can go for that. So we can go for the manganese oxide. We started with manganese because it's a cheaper material, and also you have different oxidation states, so that can be useful, and also different crystal structures also. So you can use those things also because it has a tunnel structure and other things also. So we started with the manganese oxide. I can show you some results. You need not understand everything. Okay, this is a CV. Okay, cyclic photogram. First one. Second one is a galvanostatic charge discharge. Okay, so as I shown earlier also, it's a rectangular. It's not a pure. When you go for the material, it is not a pure rectangular, and also it's not a exactly the triangular, but it has a symmetry is there. Okay, so on the basis. So if it is a rectangular, it is a supercapacitor material, and the CV area can be identified for calculating the specific capacitance. Okay, if the CV areas are higher, you have a more capacitance. If it is a less, then you have a less capacitance. So we prepared the manganese oxide in a different form, like alpha, beta, gamma, eta, lambda, like that. We prepared different types of manganese oxide, and we calculated the specific capacitance, and you can tell the which one is highest. Okay, we found that alpha and gamma are highest one. We found that. So this can be used for further one also. Okay, so that's the way we have proceeded, and then we go for the composite. Okay, so alpha MnO2 and HMO3 also we added. We make a hybrid material because high ionic conductivity and better charge transferability. So these are some of the advantages. We also made it, and we formed some particular ratio, and we made it also. Then we found this material particular form. You have the capacitance is 412. So previously you have seen some 258 something. Here we have increased the capacitance like a 412. Okay, so likewise, so some form of single phase, it is not there, you can go for composites. Like that, you can like literature or some idea, you can make it, and you can further proceed also. And this material also some problem, metal oxides, but you can easily prepare, but some limitations, like when you go for high energy densities during the time, this material, the specific capacitance drastically reduced. So we can think of another material. For that, we go for lanthanum based perovskite materials. Perovskite material is a AbO3 structures, that's called perovskites. Okay, so these materials can be useful because it has some advantages like thermal stability, high oxygen vacancies, structural stability. These are all some advantages. But the problem is when you are using high temperature and all, this material make agglomerated. Once it is agglomerated, you will have less surface area also. So what we thought is we can improve these qualities like less agglomeration, avoid the agglomeration as well as increase the porosity. So we prepared a material with less agglomeration using the lemon juice added one. Okay. For example, we need a clean environment. So you can use citric acid. It's a chemical one. So, but when you use a lemon juice contains a citric acid as well as ascorbic acid. So that can be used for some structure guided agent, like it can be used. Okay. So when without juice, lemon juice, we formed a high degree of agglomeration. But when you use this lemon juice added preparation technique, there you can find the less agglomeration. You can see the particle individually also. So that can be also reflected in the cyclic voltammeter also. Like this is the one without lemon juice, and this is the one with the lemon juice. So you can see the increase in the surface area. So that increase the area under the curve is higher, so you can have more capacitance. Like that, you can improve the things also. Okay, same thing it is given also. Then you can whether this can be prepared in a porous form. That's a very interesting thing. We made prepared this perovskite material in a porous form. Then we found that drastic good results. We found it. Okay, so this is a spherical one, and this is a porous one. Okay, you can see the area under the curve is enormously increases, and the specific capacitance also high, 580 farad per gram also. And also one more interesting thing is this can be go for the very higher cycles also. Okay, we can run for the number of cycles or more than a lakh. Okay, how it can be done means, so when you do the electrochemical cycling process, so whatever the pores which are created inside the material, this can create a proper channel also. Okay, once you created a channels, once you subjected to the charging, discharging, these ions inside the one easily, electrons or ions which can easily move inside the material, and it can be run for several cycles also. So that's the way this work also very interesting one we proved. Okay. So next one is a 2D material for electrochemical energy storage. So nowadays this 2D material also very important because it has a surface area is very high, superior flexibility. For example, nowadays people started thinking of wearable electronic things. So for that, this material can be used in a better way. And also you have a mechanical stability, everything is good. So in that sense, people started using on the 2D materials, particularly graphene. You might be knowing that it's a material. So after graphene, so molybdenum disulfide is extensively used by the researchers because it has some advantages, like a charge can be stored in a different form, like redox mechanism, EDLC. There are different ways you can store it because it has some layer structures. So in that, people are thinking on and working on the material also. Similarly, other materials also, phosphorine, mexine. Mexine is nothing but the metal nitrates or metal carbides which can be used also. So like that, people are working, searching for the advanced materials. Same material, but they can modify according to their requirement also. So we concentrated on the most material. I will finish it very fast. Okay, we are not going into the details. So depending upon the coordination number, okay, the metal atoms which is sandwiched in between the these sulfur layers. So that's why it's a MOS2. And depending upon the layers, okay, this can be in the form of a metallic nature or this can be in the form of semiconducting nature also. So 1 means it's a number of layers in the material, and T means trigonal, hexagonal, I think rhombohedral. So these are all the representations in the form. Okay, so metallic, the semiconductor, instead of metallic, if you are making the material in a metallic form, so which can give the high conductivity. So people are trying to make a metallic MOS2 material, and we made a metallic MOS2, as well as we made some composition also, like RGO. We combined this material with the graphene nitrates and some carbon spheres also we made it. And each one has some advantages, and we studied. And finally, we made to use the material as a charging, discharging, and we we light the LED with what we have made the one also. Okay, and also this material like 20 MOS2 with the carbon composite, which can give the 20,000 cycles also. So that gives retention of your material also. Okay, I'm not going into the details, just I am telling you overview. Some practical demonstration also there. So if you have a time, I can show the one video also. Now I can, I can conclude like that. You can prepare different oxide materials as well as some layered material also. And any method of preparation, one can control the size and shape of the material. And this material can be used for energy as well as environmental field. And this is a very thrusty area as far as present scenario. And we also tried some possible applications and future plan, like we can use our material for some supercapacitor applications. That's why we are looking into that. I thank my students, all because of my students and funding agencies like DRDO, DST, Nanomission and TechCube, and our MHRD fund also. Okay, that I will stop here. Okay, I can show some one video if you I can share. Sorry. Can you able to see the video? Hello?
Sir? Yes, sir.
Can you able to see the video?
Yes, sir. But
Okay,
just
okay.
picture only I can
Yeah, I
see.
will run it.
Okay.
Yes, now they are charging the material. What we have prepared the material is this one. Okay, this material is made it. It's not like a regular way. Okay, like battery cell and all. We have some form, but we have made it our laboratory way. And now it is charging. This material is getting charged with the battery. Okay, so after that, after charging, this can be light up by our material. Okay, yeah, now it is removed. Now after charging, this can be connected through LED. Okay, so now the LED is glown by our charged materials. Okay, so one minute they charge, and it can be run for 30 seconds like that. So, but we don't know how much quantity, how we can make it as a industrial form. Those and all we require some industrial people or some expertized advice from expertized people. So these are all the things required. Okay. So I will stop. Okay. Okay. Thank you for your listening. I hope I can give my overall view, but not a very detailed way because it's a heterogeneous group. So if I give more detail on the research also, it will be not good. Since this talk is mainly for attracting the students towards the research. So if somebody is coming for research, that is enough for a success for my talk itself. Okay, as I told you, so last time one student came and joined for research. I don't know other people where they have joined also, but this kind of a talk is mainly for attracting the students for research. Okay, thank you for listening. Yeah, thank you.
Yeah, thank you so much, sir. Thank you so much for giving wonderful lecture on the topic nanomaterials for energy and environmental applications, which is really useful to each and everyone, and it motivates and it stimulates all the participants and research scholars to do more project upon the nanomaterials. Thank you so much, sir. Thank you. And this is the time for the question session. And I request the participants, if you have any questions or if you have anything, you can raise to the sir. Sir, just one more request to you, sir.
You can approach me for other details also.
One more request to you, sir.
Yes.
We send you mail, the price list in your mail. You can check it after the question session, and after the report, we can have a price distribution, sir.
Okay.
Then I will call you, sir.
Okay, thank you. So I'm checking
the participants. I request all the participants, if you have any questions, suggestions, or any compliments, you can raise your questions now.
Sir, one more question, sir.
Yes. Yeah, continue. Now I'm doing other work. Okay, you continue. Yeah, I will tell.
So some questions from the chat box, sir.
Chat box, can you read that one? Because I'm doing other work. So
yes, sir.
Yes.
So many metal oxide degrade the MB dyes. If degrade the metal oxide, where is methyl is degrade in solution?
So many
metal oxide degraded the MB dyes.
Yes.
If degraded the metal oxides, where is methyl in degrade in solution?
So actually, for any degradation process, first they will study put the material like your dye into the water, and they exposed the sunlight or some light, and whether is there any degradation or absorption of this material, that can be studied initially. Then mostly they don't find very small percentage, like 4 to 5% they might have seen also. Then after that they use the dye with your photocatalyst. Okay, they use. Okay, during the time. So once you put your material inside the dye solutions, then some particular concentration. Okay, depending upon your nature of your material, you can take some concentration like 25 milligram or up to 100 milligram you can take and put it inside. Then you can study the one. So during the time, if you expose the light like sunlight or some other light, okay, laboratory, you can make some blue light or some other light depending upon the band gap you can create, and you can see the what kind of a degradation is happening. So in that, so how these color changes. Okay, for example, you are once light falls, so the electron goes and holes creations, and after that these electrons and hole, so what kind of interaction with this water and other dye. Okay, so sometimes it can create oxygen radicals or holes, these holes and oxygen radicals, which can be responsible to demantle the structure of the dye. Okay, the dye has some particular structure. Okay, I'm not so familiar with this chemical structure. Okay, there are some papers, it is there also. So you can, this dye, whatever the radicals or the holes, so which can go on with the structure, and this can remove the collapse the structure. Okay, so that's the way this can be degraded, this color. You can obviously, what kind of a change you can see is change in the color. Okay, methylene blue means initially it is in blue color, so after the visible changes with the naked eyes, you can change the color. Okay, that's the way. But you can study using the UV studies also. Yeah.
Excuse me, sir.
Yes.
It's very nice presentation, sir, and very informative. Thank you very much, sir.
Okay.
Sir, in the demo, you operate in the
Yes. Yeah.
In the demo of supercapacitors.
Yes.
You use some mesh, no, like a mesh. You are connecting to the battery.
Yes.
Yeah. So in that, what is the electrolyte, sir? Means.
Electrolyte, we use PVA and KOH, like a gel.
KOH gel means it is in dry form or it is in wet form, sir?
Gel means
during the connection.
Yeah, like paste form.
Paste form means it will not get short circuit or something because of
yes
moisture.
Yes, but it's it's not a complete one, so just a testing kind of a thing.
Yeah, it's very interesting, sir. So
okay.
we are also looking for that.
Okay.
The mesh coated with your material, and in that gel form of KOH.
Yes, yeah, that sometimes you can use some filter paper also. You can use like a membrane also, and you can paste on that one, and you can both the cathode and anode materials. You can couple and you can make things.
And it should be in wet form during our reaction, no, sir? If it is dry, then
while studying, it is in wet form. Okay.
Okay, sir.
Well, cyclic voltmeter or some studies it in wet form, but while coming for this applications, so you can make like a gel form, okay, solid form.
Solid form. Okay, sir. Okay. So how can you please suggest me how to do that KOH gel, sir, process? If you don't mind.
So which material you are working?
We are working on doing an KOH only generally.
Okay, then KOH only people used to study for cyclic.
Cyclic
yeah, yes.
So we are doing supercapacitor application and we are doing metal oxides as well as polymers.
Okay.
So for that we are willing to prepare some like sophisticated equipment or some output has to be like yours.
Okay.
So we would like to, we are searching actually because there will be problem with the electrolyte or leaking of electrolyte. So you gave me some like good demonstration, no? So there is no way of leaking also.
Okay. So you can make a PVA KOH gel, then you can make it, I think, easily.
Okay, sir. Yeah, okay, sir. Thank you very much, sir. Thank you.
Okay.
Any other questions from the participants? Any staff members? I think any questions in the chat box? Just check it.
Sir, one question from chat
Can you
box.
read? Read because.
Sir, the question is, which range of band gap energy is suitable for photocatalytes application like 2 electron volt to 3.5 electron volt?
Okay, the visible range means it's less than 2.8 and above 2. So that is a visible range. So if you want to make use of sunlight, so you can go better in the range like in between 2.8 to 2. It's better.
Okay, any other questions? If you have any other questions, we will continue, or else we will wind up the session. Dear participants, any other questions? Okay. No questions. Okay. Sir, thank you so much, sir. Thank you so much. Thank you. Thanks a lot for spending time with us, because even your busy schedule, you have sparing time with us. Thank you so much, sir. Thank you so much. I remind you, we will send you the mail to you. Just check it. The price list is there. After the conference report, you can. We will call you, sir. Then you can announce the prices.
Yes, I took the mail and I have with me. The results are with me.
Okay, sir.
So you can start the concluding session also.
Okay, sir. Okay, thank you, sir. Just I remind you, sir. Thank you so much.
Thank you.
Meeting and potting is common in our life. These 2 days, dawns and sits, have been waiting for us. We have the chance with the assembly of esteemed personalities in the international conference. Sun shines always, but here, shines only shines. Yes, it's a moment of farewell. All we have done, fair and well. I'm so delighted and pleased to welcome you all to this precious and pleasurable and blessed moment. Yes, it is a time for the valedictory function, nothing but a kind of victory. I would like to call upon and I would like to invite Mr. K. Ramesh, Head of the Department of Physics, Vivekananda College of Arts and Science, to report the conference. Welcome, sir.
Good evening to 100 person here. I am Ramesh, Head Department of Physics, Vivekananda College of Arts and Science for Women Autonomous, Ilayambalayam, Tiruchenkodu, Namakkal District, Tamil Nadu. First of all, I would like to thank our chairman, sir, for giving the permission to conduct the international conference. Thank you, sir. Thank you very much. In this wonderful occasion, I have great pleasure to present the report of the 2-day international conference ICAMS 2021, conducted by the Department of Physics. The conference was started with the prayer song. In addition to that, our college principal delivered the welcome address in this conference. Professor Dr. S. Kuppusamy, Executive Director of Vivekananda Educational Institution, gave the presidential address of the conference. And the souvenir of the conference was released in the presence of the Director Academic, Dr. V. Kumaravel, sir. The technical section 1 was started by our resource person, Dr. Dinesh Babu Velichami, sir, University of Cambridge, UK. He gave a lot of valuable and useful information related to material science. After his lecture, the participants from various universities and institutions interacted with him and shared their questions, suggestions, and compliments eagerly. The oral presentation was started at 12:15 p.m. on day 1 of the conference. Totally, we received 150 abstracts. From that abstracts, our team members made shortlist for that oral presentation. The various participants' presentation was successfully completed in the grand manner. In connection with that, the technical section 2 was started at 12:15 p.m. with the resource person, Dr. V. Elchelvi, National Physical Laboratory, New Delhi. She gave an effective lecture about electrochemical techniques to understand the corrosion mechanism of oxide coating on magnesium alloy. It was very useful to each and every one of the participants. Thus, day one of the conference was successfully completed. The day two program of the conference was started at 10:30 a.m. in the technical section 3 as a resource person, Dr. Shekhar Karthikeyan, University of Tokyo, Japan, gave a wonderful lecture on utilization of solar light for energy and environmental applications. It was very informative to all the participants. The poster presentation was started at 12:15 p.m. For this, we received 50 abstracts from the participants of various universities. Our team members made shortlist 10 poster presentations. The session was successfully completed. The technical section 4 was started with the resource person, Dr. A. Chandrabose, National Institute of Technology, Trichy, who gave the constructive lecture, Nanomaterials for Energy and Environmental Applications. All the participants would have a lot of information from the lecture. Finally, I would like to thank each and everyone who supported for the grand success of the two-day international conference. Thank you, Mandala, present here. Thank you very much. Thank you, sir.
Yes, thank you so much, sir. Thank you so much for giving report the conference. Now it's time for prize distribution. Here, contribution is honored by this adornment of prize distribution. Now I welcome Dr. Chandrabose, sir, to announcement of the prizes, those who win this oral and paper poster presentation.
Okay. Thank you for giving me the opportunity. So I will read one by one. The best oral presentation, Iman Lilly, Faculty of Sciences, SFX, Tunisia. Okay. It's the best post oral presentation. The second one is the best poster presentation, Vishnuruda D, RMD Engineering College, poster number 12. Okay. The third one is the best innovation work, Rafiq Mullah, PDF, Swansea University, UK. Okay, the last one, Young Scientist Award, Sri Visha, PhD scholar, JNTU Hyderabad. I wish all of them for their best performance, and maybe they will award you kind of a certificate or other things. Okay, thank you. Thank you for giving me the opportunity.
Thank you, sir. Thank you so much for your contribution of distribution prize. Thank you so much, sir.
Thank you.
Now, it's my pleasure to welcome I request the participants from various colleges, various universities, various states, give your feedback about the 2 days international conference. I request the participants from various universities and colleges, give your feedback about the conference.
Good evening, sir. Can you hear me?
Yes, ma'am. We can hear you, ma'am.
Good evening, sir. I'm myself Padmavati, PhD scholar, Vivekananda College, Ilayambalayam, Tiruchengodu. So the overall presentation was too good, sir. We didn't expect this much effectively. You will conduct this seminar in a grand manner. So overall, it was very good, sir, and it's very informative and very nice. It's effective one, sir. The 2-day time we spent for it, it's totally effective, very effective, sir. And thank you so much for organizing this great seminar for us, sir. Conference. Thank you so much.
Thank you, ma'am. Thank you. Any other feedback? Your feedback encourages more and more to the next level state and international seminars. I request the participants give your own feedback, which will help us to other participants, other students.
Hello, sir.
Yes, sir.
Myself, Dr. Satyajit Chauhan. Can I speak?
You can speak, sir.
Yeah, it was really nice with the material science spending the 2 days and such a nice conference conducted in the way that was very nice. I was afraid about how it will happen in the online conference, but the way you have organized that is very much nice. And I'm again happy that the invited talks are really having the depth of the knowledge regarding the material science and the different various categories related with the sub part of the material sciences are there. Again, the whatever the participants are there, that was present. That was very nice. That nearly more than 100-200 participants are lively present for every session. I participated or present in the every session. That's why I have seen that carefully, and it was really nice experience. And I'm very much happy that such type of the conferences are there. Still, the pandemic situation is to be there. And I hope the such type of the conferences will be organized by the organizing committee in future too. Thank you very much, sir.
Thank you, sir. We are very happy to hear your feedback. It encourages. Any other feedback from participants? We like to invite many participants to give a feedback.
Dr. Segar Karthikeyan. If you have any feedback about our conference, if you wish, you tell me.
I found this is a really great conference. I found yesterday morning and then the afternoon session. It was really.
Sir, the voice is not audible, sir. We can hear you. Voice is not audible, sir.
Okay. So actually, the yesterday conference was very good, really good. In the morning session, and over the person, the work, the end mind, really good. I enjoyed a lot during the session, and today's conference was really good in the first session as well. And some of them will disappoint due to the price. Price doesn't matter. You have a lot of qualities because when I present the conference, any conference, I will not get the prizes, so I did not disappointed. So don't disappoint these things. Get motivated and then do better than. Okay, so this is my just message. And the organizing committee youngsters really good. I hope you can improve a lot the next time because you give you getting the feedback from the audience. So hopefully it will be improve the next sections. Okay, for your futures.
Sir, sorry for the interruption. Did you finish, sir?
Yes, I finished.
Okay.
Got the points right.
Thank you so much, sir, for giving a valuable feedback, which encourages. Thank you, sir. Any other feedback from the participants?
Sir, good evening to all. I am Vishruda from a UG student
from EC department from RMD Engineering College. This session was very nice, and we are able to gather lots of information. Even though this is my first conference, I have gathered lots of information, lots of how to do, lots of experience I have earned from this from this conference. So thank you to the management for giving me this opportunity to present, and thank you all. Every presenters did a great job, and I have thank you. This made me to do more to make me more interested in further researches on material science. Thank you all. Thank you.
Thank you, ma'am. And we are happy to hear feedback from chief guest. Really, we honored to you, sir. Thank you so much. Any other feedback from the participants? Okay. Thank you so much for cooperation with us. I would like to thank all the participants and from various colleges, various universities, and I like to thank all the guests who spare time with us. And I would like to thank the technical teams. Now I would like to invite Dr. G. Gardiban, sir, Dean of Physical Science, to give the vote of thanks. Sir, I welcome you, sir. This is over to you.
It is audible.
Yes, sir. It's audible, sir.
Okay. A very good evening, and all present. That is for the right time to propose thanks. It's my pleasure to convey my heart thanks to each participants of this wonderful international e-conference on advanced material science, ICMS 2021, on occasion of celebrating 20th year of educational excellence. Most respected this of the International E-Conference on Advanced Material Science, ICMS 2021, Dr. Sandarbose sir, the Professor of Physics, the National Institute of Technology, Trichy, the most respected and secretary, the Managing Director, Joint Managing Director, Joint Secretary, Vice Chairman, Director, Chief Executive Director of Vivekananda Education Institution, the Principal, the Director Academic, Controller of Examination, of various disciplines, Head of the Department of Physics, Convener, Organizing Secretary, Faculty members, delegates of various entities and colleges, and my dear friends, and a warm, happy good evening to all. Very happy and proud to say the Department of Physics to organize today's International E-Conference on Advanced Material Science, ICMS 2021. I could see the conference had many meaningful events, 4 technical sessions, including 4 innovative lectures. First, I would like to thank you for beloved principal, Dr. Suresh Masar, for this e-conference. Thank you, sir. Then, I thank you for our beloved academic, Dr. V. Madhav, sir, for this conference. I thank you, sir. Next, I would like to thank for our today's valedictory chief guest, Dr. A. Sandarbose, the Professor of Physics, the National Institute of Technology. I thank you, sir. Dr. A. Sandarbose is an excellent researcher in the area of nanomaterial for energy and environmental applications. We are glad to have present, sir. At this time, I extend my warm thanks to guest of honor, Dr. Dinesh Babu Veluswamy, the University of Cambridge, United Kingdom, Dr. Erichelvi, the National Physical Laboratory, New Delhi, and Dr. Sagar Karthikeyan, Department of Earth Resource Engineering, University of Tokyo, Japan. Presence. I thank you everyone for valuable presence. It's a pleasure to thank to the head of the department, Mr. K. Ramesh sir, and other faculty members of the Department of Physics and faculty members of various departments to this virtual. I feel really happy to thank for the participants from this institution and also our institution, this e-conference. The theme of e-conference is mainly dealt with advanced material sciences, first one, and many researchers focusing on this subject. Hence, the conference Unite will help the participants to enlighten the research career. I wish to thank the participants for the same. Indeed, it is a great pleasure to thank you all one time for your excellent qualifications. Thank you for giving me the opportunity. Thank you one and all.
Thank you, sir. Thank you so much for giving a fabulous vote of thanks. Thank you so much, sir. It is a moment of integration. We will honor to show our integration in this conference. Let's rise to the national anthem.
शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you so much. Thank you so much for all the participants. Thank you. We can wind up the international conference with a happy manner. Thank you so much. You can leave now. Thank you all. Thank you.
Thank you. I shall leave.
கேட்டுச்சா? கேட்டுச்சா? Yeah.